care. We're driving Cadillacs in our dreams, but everybody's like crystal, Maybach, diamonds on your timepiece, jet planes, islands, tigers on a gold leash. We don't care. Let me be your ruler. You can call me Queen Bee, and baby I'll let me live that fantasy. Caught up in your love affair, and we'll never be royal. It's a running out of love. That kind of love's just ain't for us. We crave a different kind of buzz. Let me be your ruler. You can call me queen, and baby I'll rule.
git commit, and also add a title or whatever. And then I'm going to go ahead and do a git push. So when I did the G-Cloud init, I initialized my local workspace with a remote repository that's hosted for us in the Google Cloud. And now I've gone and pushed that up. So if we switch over here to the console, you'll see when I refresh this that our new source code here in the console has that change that we looked at. There it is, GCP Live. And now if I switch over to releases, we see this is the Git URL that we offer as part of every developer console project. You get a free private Git repository that's accessible to all the members of your development team on this project.
Now that's really cool, and a lot of people do use Git, but a lot of people also use GitHub, whether it's for public open source projects or even for private repos. So is there support for that too?
Absolutely, Greg. In Google, we're big fans of GitHub, and so we've gone ahead and added a connect to GitHub button. So all the features I'm going to show you work great if you use a GitHub repository or one of ours. So regardless of which you use, as a post-commit action, you have your choice as to what happens. We can do a build, run a set of unit tests before we deploy that into production. In this case, we've set it to build with Maven, run unit tests, and then deploy to our cloud platform. To give you a peek inside a little bit about what's really happening, when we configured that build, what we did is we spin up a compute engine instance. And we installed on your behalf Jenkins, Maven, the JDK, everything we needed to do reliable builds. And then when that git push happened, we pulled down all the code and did a clean build. And then when that build passed, we ran all your unit tests and then pushed it to production. So you can be more sure you get a safe, reliable deployment. And you can see as I practice this the spikes in the build machine. So if we switch back over to cloud deployment, you can see our release history. What you see here is that we added that title, we did a build, test, and we deployed that into production all in the time we've been talking here. So if we switch over and see Greg's app, Greg, it looks like a little meme application. That's kind of cool. And it's going to refresh with, and we see these, here are the memes you have. Yes, that's cute, petabytes of data. But let's, and there's the title that we added, that's great. I'm interested in what our top memes are here at the cloud event, so let's check those out. Oh, Greg, you have a server error here, 500 server error, that's not good. These kind of issues are hard enough to debug when it's on your local machine, but when you have an issue like this in production, it's even harder. So to give you a sense about debugging this in production, I'm going to switch over and give some simulated load. So just going to throw a lot of traffic at that site. I saw some of you copying down the URL, so you might be throwing some traffic at it as well. So we'll go over and look at how we debug that issue. So I'm going to bring up the new unified logs viewer. And we're getting a log entry for every request that comes in. And you saw I just threw a bunch of requests at this thing. And we're aggregating all those logs across every front-end instance that we're spinning up into a single unified view. And so now I can just scroll through here, and notice as I'm scrolling, it's loading new logs. So it's easy for me to kind of find the logs that I'm interested in. I can also filter these. In this particular case, though, I want to look for a status 500 because that's what we saw, the 500 server error. I can also come in and filter by date and time. So if I get a bug report at a certain time, I can narrow that down pretty easily. These filters can be chained together with and or, so you can get exactly what you want. Okay, so here are the errors that we're hitting. And I can see, Greg, the problem here is this in this ominously named method, get means buggy. That must be.
I had to make it easy for you to find, Brad.
Yes, I appreciate that. So speaking of finding that, you'll notice the next thing we want to do as a developer is jump into the source, because that's where we're going to be able to fix this problem. But I have all this context loaded in my head. I need to get to the source quick so I can start bringing that to bear. So what I'm going to do is notice that right here, this is actually a hyperlink. So if I click right on this hyperlink, it brings me into the console, into our source code view, with exactly the version of the source code that was deployed into production and that line of code highlighted. Pretty useful? So at this point, we could drop back to the Git command line. We could pull that file down and start operating on it. I can click on this Open an IDE button and use a variety of third-party or Google-provided IDEs. Or, because this is a very quick change, I can just click on Edit. Make this change right in the browser and go ahead and do a commit. And we'll just say fixed Greg's buggy code, and we'll deploy that into production. Now, how many of you have been debugging a production issue and you ended up SSHing into a production machine and twiddling some config file or messing with some PHP code? Who's done that? Yeah, so who's done that this morning? Okay, and that's maybe not the best idea, and that is not what we're doing here. We're actually committing this change back to the production Git repository. That change is attributed to me. It's repeatable. All future deployments will have that code as well. And we're running that full release pipeline. We're building the code on a clean machine. We're running all our unit tests, and we're deploying it only if all those things pass. Now, that takes a minute or so for those things to happen. So let's see if we can view that deployment in progress. So let's open that in a new tab. And we should see our new release. There it is. We fixed Greg's buggy code. Notice it's already built and tested that in just this short time, and we've deployed that out into production. So if we switch over now and refresh this, we should see the top cloud memes. And of course, they're all Jeff Dean memes. Guess that's how it goes. So what you've seen today is it's very easy to use tools you already know and love, like Maven, Jenkins, and Gradle to be able to target our platform. You've seen how easy it is to get reliable and quick deployments with our new continuous integration system. And finally, you saw how easy it was to find and debug an issue in production and get that fixed quickly. Thanks, Greg.
Thanks, Brad. That's really cool. I think that'll help a lot of developers make the jump to the cloud knowing that they can keep using the tools that they're comfortable with. So let's turn to the second of the big trade-offs, and it's a big one. You know, back in 2008, we introduced App Engine, which really became the first widely used platform as a service, allowing developers to focus only on the code that make their application unique and let us at Google handle all of the stuff like scaling and management and configuration, and let us carry a pager so you don't have to. But today you face a tough choice. Do I use products like Compute Engine, infrastructure as a service, that give me total flexibility on open source packages I use and operating systems and programming languages, but at the cost of me having to carry my own pager, scale my own infrastructure, build out my own management? Or do I use products like App Engine, which free me from all that, but impose certain restrictions on me, like they only let me use certain languages or certain environments? This is another case of what we think is a false dichotomy, and it's one that we want to address. We think you should have access to the languages and runtimes you want and still get the auto management, auto capabilities of products like App Engine. So today we're introducing managed virtual machines. And managed VMs are just what it says. They are virtual machines that run on Compute Engine, but they are managed on your behalf with all of the goodness of App Engine. So this gives you a new way to think about building services, combining the freedom and control of App Engine, of Compute Engine, with the capabilities of App Engine. So you can start with an App Engine application, and if you ever hit a point where there's a language you want to use or an open source package you want to use that we don't support, with just a few configuration line changes, you can take part of that application and replace it with an equivalent virtual machine. And now you have control. You can do whatever you want without giving up all the benefits to begin that you chose App Engine for to begin with. So to see this in action, I've asked Chris Ramsdale to come up. Chris is going to give us a demo of managed virtual machines. He's going to take an application like Brad used, but he's going to add in now C++ code and some open source packages while still keeping the capabilities that he thought App Engine was great for to begin with. So Chris, why don't you show us managed virtual machines?
Cool. Thanks, Greg. Appreciate it. So what I'm going to show you today is how we use managed VMs to take and add real-time image collaboration in the cloud and add that to Brad's demo. All right? So what we're going to do is we're going to have clients that are running inside of Chrome that are communicating back with a fleet of managed VMs via WebSockets for low latency communications. Right? And on those managed VMs, we're going to rely on ImageMagick, a third-party open source library that's an optimized C library for doing image processing and image rendering. We're going to use local disk to cache the renderings to make it super snappy. We're going to use App Engine's Java runtime as a serving stack to get data flowing from the front ends to the back ends. Now, as Greg alluded to, that kind of technology is not typically supported on platforms as a service, and not what App Engine is today. With managed VMs, this is totally possible. Furthermore, we make it very easy to get up and started with this. So let me show you. We're going to pop over to my terminal here. And what we see is a typical App Engine configuration file with a few parameters. So we have an application, we have a version, we have what module is running. With a few more lines of configuration, we're actually going to turn this into a managed VM. So let me walk through these settings here. So the first thing is we're setting VM true. That's telling the system I want to run this on a managed VM so I have access to native resources and the ability to run native code. Furthermore, we get into a new section called VM settings. Here we specify machine type, for example. And since we're doing image rendering and image processing, we're going to crank up the horsepower on these VMs and deploy 8 core machines.
Now this could be any of the Compute Engine virtual machine types, 1, 2, 4, 8 or more cores, high mem, high CPU standard, whatever's available in GCE, you can use with App Engine as well.
Absolutely, Greg. And furthermore, as we innovate here, those innovations will flow back to this configuration as well. The next line is the settings for deploying the third-party code that I want on those managed VMs. In this case, we're using ImageMagick and just doing apt-get install to those managed VMs.
And again, anything installable via apt-get, I can specify here, and it becomes available to me in a managed VM.
Absolutely. This is how we're opening up App Engine so you can use third-party libraries like that and get them onto those VMs, those managed VMs, in a super simple way. The next line is we're opening up a port. In this case, it's an arbitrary port, 65080, and that's how we're going to do the WebSocket communication from the clients that are running in Chrome back to those fleet of managed VMs. And then for the sake of this demo, we're going to specify 2 instances because that's more than enough for this demo, especially since we're running 8 core machines. So we're going to escape from this, save it. And now since this is since we're running on a Java runtime and it's a Java application, we can use Maven to deploy this. Okay, so while that's running, I'm going to talk about what's happening under the hood. So if we can cut back to the slides, please. All right, the first thing that's happening is that we're relying on our gcloud tools to parse and validate the configuration file that I just showed you. Assuming that's valid, which it is, it's going to communicate to our deployment endpoints and say, okay, I want to deploy this application. Those deployment endpoints are going to store some metadata about the application, the version, the template, the number of instances that are running. And then from there, we're going to go off and we're going to create the actual containers. In this case, we're creating 8 core Compute Engine VMs, and we're installing our Debian OS on top of that. After that, we're going to carve out the managed services and make sure that everything's lined up correctly for you. So in this case, we're doing monitoring and health checking, task queues, memcache, and data store. We're also going to create secure namespaces so that everything is secure within those multi-tenant systems, and we're going to set up smart defaults so it's very easy to access the APIs and get data flowing back and forth. From there, it's onto the serving stack. And since we're running on a Java runtime, we're going to install a web server, an application server, and a JVM. And then it's on to the interesting parts, the parts that you provide. So in this case, the third-party code we specified, so ImageMagick on those managed VMs, and then most importantly, your code. We're going to bring all that up, we're going to do some health checking, make sure everything's running correctly, and assuming it is, we're going to install a load balancer, and then we're going to wire everything up for you. The final step is we're going to take all of that and make sure it's co-located with the other pieces of compute that you're running. So in this case, Brad had showed you some front ends that we're running. We're going to take your managed VMs and co-locate those with your front ends so you get low latency and improved overall performance. All right, so if we can jump back to the demo. All right, so our build succeeded. Let's go check that out in Chrome. So we'll pull this up. We'll navigate to the URL that's provisioned for us. All right, and then we see our new front end, Cloud Collabo, collaboration in the cloud. This is pretty straightforward. We're going to be able to upload an image. We're going to do some edits to that image. Those edits are going to be shown to the people that are collaborating, and then we're going to do some real-time conversation back and forth. So let's pick an image. All right, meme 2 looks good. All right, man of the hour, Urs, we're going to use his meme to actually get going. So that's uploading to cloud storage right now. All right, there it is. So it's uploaded. You see that I am the only collaborator, so let's change that. I'm going to share this with Greg. Now, demo note, I'm going to use Chrome profiles to simulate Greg and myself communicating back and forth. So we're going to bump over to Greg's profile. Oh, yes, looks just like you, Greg. Oh, you're the Spook Movie fan as well. I love it. It's great. That is like the craziest thing I've ever seen in my life. All right, back to business. Okay, so I'm sharing this with Greg right now. It's going out. It's going to log him in. Wait for it. Okay, there he is. All right, and you see now that Greg and I are collaborating on this image. Now to show you happening in real time, I'm going to try to move this over here. Okay, so I'm going to pretend that Greg is actually doing the editing, and you're going to see things happening if everything works correctly in my browser as well. So we'll dress it up with a frame first. Nothing goes with green like magenta. Grab that. Say add border. All right, good, we've got a border. Now we're going to add some high-end doodling. Now somebody had mentioned that doodling on Urs's image is probably a career-limiting move. But I said, hey, why not?
Only if the demo doesn't work.
Exactly. All right, so we're going to give Urs a big smile. Good prices in cloud. His famous earring and more bling. And there we go. And now we see that it's happening in real time back to my browser. And so then what's happening is that these two clients are connecting over WebSockets back to the managed VMs. We're doing the rendering, we're caching in local disk, and we're sending the updates back to the Chrome clients. Now I want to take a second and say to all the App Engine developers and users that are in the crowd that like, this typically wasn't and was not supported on App Engine, but yet it's been a top feature request consistently year over year. So I'm happy to announce that those feature requests are now fixed and available to you. Okay, so it's not just about, thank you, all the App Engine developers in the crowd. So while ability to access native resources and run native code on these managed VMs is fantastic. It's not just about that. It's about great developer experiences and great developer integration. So to show you that, I'm going to bump back out to the developer's console here. So here. Okay, so same UI that Brad had shown previously. It's our developer's console. And I'm going to show how we've integrated App Engine and Compute Engine by drilling down into the App Engine tab. Okay, we see our dashboard. We see our modules. I'm going to select our backend module. That's the one that's handling all the real-time collaboration and communication. We'll drill into the instances. And here we see the instances that are running from my application. So remember back in the configuration file, we specified that we want 2 managed VMs. Here we see those, and if we drill into this VM over here, give it a second, okay. And so there's the dashboard for the underlying VM. And if we move down on the page, we can see that it is in fact an 8-core machine. We've automatically configured an external IP for it. And there's some metadata here that allows us to manage the VM, quite a bit of it actually. So that's drilling down into the VM. Now let's bubble back up and see how we've integrated all the managed services. If we come back to the App Engine tab, we'll go to our Unified Logs viewer. Now what's nice about this is it's not just unifying the logs on all my managed VMs, it's actually unifying the logs across all the compute that I'm doing, be it a front end running on App Engine or managed VMs that are running on top of Compute Engine VMs. So here we see that there's a fair number of servlets that are being hit for my backend. Got one for serving a middle image, one for creating a WebSockets connection. And while you could do all of this on an unmanaged VM, you could do it on a raw Compute Engine VM. You could deploy syslog or rsyslog. We think there's a more productive way. We think that by offering a managed and centralized service like this, you can become a more productive developer. And furthermore, if you apply that philosophy out to things like authentication, deployment management, configuration management, developer tools, developer console, that you can be a more productive and happier developer for the cloud. Now let's take a look at how, speaking of developer productivity, let's take a look at what we do with the underlying VMs. Now, we had mentioned that these VMs are locked down by default, so they're not, you don't have root access, you don't have SSH access into them. And that's for good reason. We don't want people going out into production making changes to one of those VMs that are running inside of a large fleet. It makes it hard to manage within a high availability manner. But we recognize the fact that there are times when you need to get to those VMs to do things like do some kind of debugging or check on a configuration file that you have or make some configuration change just to see what happens to the underlying VM. We'll make that super simple as well. So if we come back here to the terminal, we're going to do a gcloud instances, gcloud compute, instances, list. Okay, and there's our 2 VMs that are actually running. And now we're going to enable debugging for one of those. So we'll do gcloud debug, compute, debug, use the local directory which has the configuration for these managed VMs. And what that's going to do is it's going to go through that deployment endpoint and put those 2 managed VMs into debug mode, which is what you're seeing here. I'll clear that up. And if we do gcloud compute, instances, list again, so I can grab the name. Let's grab the first one, we'll SSH into that. Let's grab that guy. Instead of list, we'll do SSH. Okay. So now that I'll SSH us into the underlying VM, what you see here, Cramsdale at AE-backend1-0, clear that up. Now once you're on this VM, you have access to common tools that you would normally use on a virtual machine. In this case, we can do things like run netstat. Right? And we see all the activity that's running through the various connections on the VM. In this case, we can actually see up there at 65080 with the port we're listening on for the WebSockets. You can see up there at 65080 with the port we're listening on for the WebSockets communication. And then we can do things like interact with the Debian package manager to see that the package that we specified inside the configuration file is actually on the VM. So in this case, we'll do dpkg and we'll do a grep for, let's say, magic. Right? And sure enough, there you see that in the bottom, you see that our package is actually installed on the VM. And so all we're going to do is we exit. We'll see that VM back up, and things are good to go. So what we see here is that with managed VMs, we can take advantage of the auto management that App Engine provides with the control and flexibility of underlying Compute Engine VMs. We can make it super simple to get started with easy configuration, easy deployments, integration back with managed services, as well as integration with our developer console and our developer tools, right? So that we don't have to make a choice between, oh, I want platform as a service and auto management, or I want to choose flexibility with Compute Engine. Managed VMs brings both of those together, giving you the best of both worlds. And so with that, I'm going to turn it back over to Greg.
Thanks, Chris. So there you really saw the ability to blend auto management and flexibility in one offering. We think that's going to be a great way for developers to be more productive. So the last hard problem we want to talk about today is a big one. It's all about data. Big data is really revolutionizing the way people deal with analytics. And companies are able to get insights from data that was never before possible. It was previously just sort of a mass of data they couldn't make sense of. But if you take a look at most big data deployments, there's a lot of work in those that has nothing to do with analytics. It's about moving data from A to B, or sharding it so it's efficient, or transforming it from one format to another. None of which is actually about analyzing. It's all about setting up so you can analyze. What you really want to be able to do is take data as it's generated in its raw form, ingest it in real time as it's being generated, and start analyzing it the minute it's in your system without having to go through intermediate warehousing and transformation steps. And that's really why we first built BigQuery. BigQuery, you probably know, builds on a tool that we developed internally at Google. Early on at Google, we realized that we had to find a way to look at the log files of massive numbers of front-end web servers to see what's going on. And we knew that none of the existing data tools out there would be anywhere close enough. So we built an internal tool for that, and BigQuery is built on top of that. So it uses the same technology we use to do massive data analytics of front-end web servers, but with a very friendly SQL-like syntax. So back in September, we introduced in BigQuery a streaming API. And BigQuery streaming allows you to take data as you're generating it, whether that's from applications or from physical devices, send it into BigQuery, and as soon as you send it to BigQuery, it shows up and is available for analysis. Well, we started out allowing you to ingest 1,000 rows per second into BigQuery. Today, we're taking that to the next level. We're announcing BigQuery streaming supporting 100,000 rows per second of ingestion. So what that means is you can take massive amounts of data that you generate, and as fast as you can generate them and send it to BigQuery, you can start analyzing it and drawing business conclusions from it without setting up data warehouses, without building sharding, without doing ETL, without doing copying. So to give you a demo of exactly that, of real-time large amounts of data being analyzed in BigQuery, I have a special guest we want to bring up. I want to bring up Eric Schmidt. Not the chairman of the board of directors, Eric Schmidt, the Eric Schmidt from the Cloud Platform team. Eric?
Thanks, Greg. I'm a solutions architect in the cloud platform team, not the chairman of the board. So, in this demo, I want to demonstrate how you can leverage BigQuery to do near real-time interactive analysis over rapidly changing massive data sets. As Greg just talked about, we now have the ability to ingest 100,000 rows per second per table into BigQuery. For this demo, I'm modeling some use cases from a company called Glen Canyon. Glen Canyon is a pioneer in smart meter and intelligent network technology for electric power utilities. They have millions of meters in market today. This is an example of one of them. They communicate over Wi-Fi and 3G. For our demo, we're going to have these meters report out once a minute, 60 events an hour, and I'm going to virtualize these meters over the city of Seattle, which roughly has 400,000 meters in its network. At the end of the day, we're going to be processing around 17 billion events per month. You can flip over to the demo machine. All right. So the first thing I want to do is just dive into a couple of very, very simple queries to give you some context about what's happening with the system. On my other machine over here, this is my meter system. I'm generating load to create hundreds of thousands of meter requests. This query here, I'm just going to do a quick count from my single table that I'm doing raw ingestion of records. I apologize to all my DBA friends out there for doing a select star with no where clause. So there you go. We have over 4.6 billion rows in this table. We're doing around a billion per day. So this is roughly a little over a week's worth of data. So what does this data look like? I'm going to go and look at my raw data table. I'll scroll down. Oh, first get details. Scroll down. And you can see down at the bottom, I have individual meter ID, the read time from the meter, its status. The status is very important. How many of you had to call the electric company to tell them that your power's off? Wouldn't it be great whenever you call them, they tell you? You have active energy. This is how much kilowatts per hour the home or business is drawing. And if I scroll all the way out, I have things like the actual temperature of the meter. So temperature increases of a meter typically indicate some type of mechanical failure. And finally, you have the insertion time, the time that the record was actually inserted into BigQuery. This record on a case-by-case basis is 128 bytes. So roughly, we're building around 2 terabytes per month just for the simulation of Seattle. But if you want to put this into perspective, you start multiplying the number of cities on the planet, you're talking about hundreds and hundreds of terabytes into petabytes. So what can we do with this data? I'm going to flip over. I'm going to re-render this. This is a real-time visualization of all the meters in Seattle, all 400,000. This visualization is powered by a standing query that I'm running that will calculate all of the average power for the entire grid. So you can kind of see this mean energy that's being drawn across the screen. It's a sliding window of approximately 10 minutes. So every second I'm streaming on average around 8 to 10,000 records into the system because I have it completely distributed. And BigQuery is constantly ingesting and enabling me to query that data in real time. Now, let's go ahead and zoom in and try to find a location because it's kind of hard to see what's going on this map with so many points. So I'm going to find my local coffee shop on 19th, Fuel Coffee. If you're ever in Seattle, they have great coffee. I'm going to go ahead and re-render this map, and in the background, I have run another query that is doing geographic analysis just on the lat and long boundary for all the points that are in this view. So if I start clicking on them, I can go ahead and get some details specifically about just this meter. The interesting thing here to point out is I have one table, one single table for me to do my aggregations that I just showed you in the previous graph, or these graphs that are looking at specific atomic records, the active energy as well as the temperature. So I can go ahead and click around.
And this also shows, right, how BigQuery is not only for interactive analysis, but you can actually build applications that sit on top of BigQuery to do visualizations at the API level as well.
Exactly. So some of the queries that I'm about to show you that I was using in the console, those are running inside of a set of Python application as well as a Java application to power this visualization. All right, let's get back and look at some queries. This query is the average power by time, and I am going to go ahead and run this. This is fundamentally the same query that was powering the overall averaging of that entire system. Now, you'll note here up top where in my from statement, I'm using a relatively new feature inside of BigQuery called table decorators. What this enables you to do is basically filter down the rows that you would like to see that have been written into a particular table in a given time window. So fundamentally, I've taken 4 plus 4 billion rows and narrowed it down to roughly 800,000. This helps with query performance as well as reduce query cost. So you can kind of view table decorators as a simplified where with some benefits. So there you go. There's the average of the entire system right now, around 5.7 kilowatts an hour. This is interesting. I can do real-time, near real-time interactive analysis over lots of data, but let's write a bigger query, because after all, this is BigQuery. This query is the basis for the query that I was running whenever I was zooming in on my geo-coordinates. And one of the things I want to point out here, Urs talked about this morning, released a feature last fall called join, or big join. In this case, what I'm doing is I am joining my raw meter table, those 4 billion rows, to a metadata table that contains all of my lat and long information for my meters. This is a great way to maintain normalization in your database. I'm a big NoSQL fan as well, but one of the challenges is you end up muddying your tables with lots of redundant data. Well, with the power of join, I can go ahead and just filter out, given lat and long, the meter IDs that I would like to address in my query. So I'm roughly filtering down to a couple hundred inside of that view. And I'm averaging and also looking at their status to see if they're off and on. It's fundamentally the same query I was running before, except I'm using joins to filter out on lat and long. Now, I can average, so I have roughly probably 200 to 300 in this view, and I'm averaging so I can see who is the highest user. I do a sort at the bottom of this query. I want to see who's the highest user of power on average. But the other thing I did in this query is leveraged cross joins and a statistical function called quantiles to look at the entire 400,000 meters that are in this system and look at the quantile distribution. I have 100 steps in this distribution so that I could compare an individual meter to the entire population. So I'm fundamentally taking 4 billion rows, narrowing it down to around 800, doing a join, and then doing a quantile back on the entire grid system. It's a big query. But you'll notice I only processed around 200 megabytes of data. I didn't process gigs of data. And I did this in roughly 15 seconds. So there you go. Meter number 163236. They are the highest average user in that GeoGrid. And ironically, they're also in the 99th quantile, because my data is all completely randomized, but it's randomized with the same patterns. Now, this same type of query, you might not even be able to run this if you were running in a NoSQL environment, or if you didn't have the processing power, you may have gone to lunch and then came back, right? So, I have one more query to show you. While I've been running this demo on my machine over here, just making sure that our system is still up. Instead of running the system to report every 60 seconds or every minute, I've asked the system to report out roughly every 7 seconds. Functionally, I've taken 400,000 meters and turned them into 2.8 million meters. This equates to roughly around 45,000 rows per second being ingested into my table. Not doing any sharding. I have one table to do all of my analysis off of. Now, if you needed to do further RPS, you could shard, and you could use something like wildcards, and you could get hundreds of thousands or millions of rows per second into BigQuery. So there you have it. All of your data in one common environment. You have a friendly SQL-like syntax. You have high throughput, low latency ingestion to do near real-time interactive analysis at democratized pricing. So thanks for your time. I hope you enjoy the rest of the show. Please turn off your lights and go big data. Thanks, Eric.
It just blows my mind that while Eric was doing that demo that we were putting in 45,000 new rows per second while he's doing the demo live. He gets like the gutsy onstage demo award for the day, I think. You know, when you look at everything we're doing, this is a great time to be a developer. We're going to have drill down sessions on all of these technologies throughout the day, as well as product managers and engineers to help you answer your questions. So with that, I'm going to turn things back over to Urs to sort of wrap up, and thank you very much for your time.
Thank you, Greg.
Thanks, Urs.
All right. Well, as Greg said, this truly is an exciting time to be an engineer, because you can build an application for a global audience, and you have to do very little to do that other than focus on your problem. That is our goal. The amount of change and innovation around us that's happening right now is really incredible. And that creates a huge opportunity. And what we want to do is build the cloud platform that you want to use to take advantage of that opportunity. So really, a lot of what we focused on today was productivity. Right? How do we make you more productive in developing in the cloud, make it easier to build and test and deploy in the cloud using the tools that you already know. And then with managed VMs, you can have the flexibility of the auto management of App Engine with the flexibility of VMs. You don't have to choose between the two. And then as we just saw, BigQuery allows you to make big data analysis really just work at any scale. You don't have to choose between really high scale, interactive querying, or real-time data. Right? All these three things you get on one tool, one single tool on the Google Cloud platform. And on top of that, of course, we have made this all more affordable than it's ever been before by following Moore's Law. Because we believe that the price of virtualized hardware should follow the same trends that the price of real hardware followed. Really, Moore's Law is here to stay, and you will see that in our cloud. Now, on top of that, I have shown you how you can get additional discounts for sustained usage, but without upfront payments, without lock-in, without long-term commitments, and really without the planning hassle that you have to go into with other providers just to get a good price. So this is really a new way of thinking about pricing, I think. A way where we move the planning hassle from you to us so that you can focus on the things that you actually want to focus on. So everything we're doing with the platform really is about making you more productive and helping you, the developer, to do the things you love and let us do the rest. So we introduced a lot of things today, but it's just March. So you can look forward to a lot more later this year. And I'll certainly see many of you at Google I/O here in San Francisco in June, when we will have a lot more to say about the Google Cloud. But before we get there, we're going to go on a tour, a developer roadshow, starting 2 weeks from now, going through 27 cities worldwide. So look for that at cloud.google.com/roadshow, and I hope to see some of you there as well. So with that, enjoy the rest of the day, all the detailed sessions. Thank you for putting your applications in the Google Cloud. Thank you for attending Cloud Platform Live. Thanks.
Good job.
Yeah, this one, Glenn? Yes, I was going to go.
to speak with animals.
Hey, Lois, can I just look at the slides real quick? Sure. I just want to make sure they're the, because we
doesn't appear to be plugging in.
Okay, there we go. Give it just a sec. There you go.
No, I'm not seeing pick up all.
Okay. Yes. I don't know. I don't know. That's not good. You gonna try and do Wi-Fi? Okay. But still, do it over Wi-Fi, man.
I think we tested yesterday. This is working.
Okay.
Then you did for testing.
Okay. All right. Yeah, we just network. We just got to get network working.
I just want to try to hide these cables.
Sure. The network guy says good luck.
Want to give it just one click to make sure the clicker is working?
Oh, sure.
Go back.
What should be a good 30 minutes? What do you said, 30 minutes? 30 megs. Oh, okay. Like 30, we're going to... What the hell? Yeah, we're ready. So you're going to signal us or... No. To get started? Okay. Okay. Oh, okay. Yeah, when the clock starts. Okay, yeah. No, that's very helpful. Okay. Okay. Yes. Okay, so you'll just point at me or something? Okay. Okay, good morning, and thank you for coming. You're on the tour of the Google Cloud Platform. I'm Brad Abrams, and I'm a product manager on the Cloud Platform team.
And I'm Brian Lynch. I'm a solutions architect on the Cloud Platform team.
So in order to give you this end-to-end tour of the platform, we thought we'd build out a real application. So, mic's not working. Mic is not working. Am I doing something wrong? I seem to be on. Am I good? Am I working? Hello? Should I wait? Anybody have any Google questions? We can just do the Q&A here while we wait. Seriously, any questions so far? Yes. Yes. So the question was, can I take logs and pull them into BigQuery? And we're going to talk a little bit about that in Scene Inside Your Service. But it is possible to do that. Can you hear me now? Can you hear me? Still can't hear me. Okay. Just talk louder. I imagine our friends in London probably still couldn't hear me if I talk louder. Okay, I'm going to assume the AV guys are going to tell me what to do at some point. Okay, so other questions? What was your favorite demo during the keynote? Manage VM, the live migration. Okay, fine. Okay, okay. This. Okay, hello, are we on? Awesome, okay. So welcome, let me start again. Welcome, this is the end-to-end tour of the Google Cloud Platform, and I'm Brad Abrams.
And I'm Brian Lynch.
So we thought to give you, no? Brian, are you working?
Can we get a second mic?
Now what's happening? What's happening now?
No. There we go.
Okay, good. Okay, round two.
Yeah.
Okay, now we're at the end-to-end tour of the Google Cloud Platform. You've gotten all settled and you're ready to go. We thought in order to give you this tour, we'd build out a real application. We're going to extend that cloud meme application that we saw in the keynote. And we're going to show you some real business logic written in App Engine and having that run on the server. And we're going to build that application in just 50 minutes that we have left here. So I think that's going to be great. Don't you think
Wait, Brad, let's build something a little more real world. I mean, you're just talking about an App Engine app. I mean, it's a meme. We're going to have to store these memes somewhere. So
well, I think we may have time. If we push it, we may have time to also store the images. Let's store that in a cloud storage bucket. Okay, so I think we can get these two things done.
Wait, hold on. We've got to store the metadata somewhere. You're going to have metadata. You're going to have user info. You're going to have voting maybe. You're going to things associated with the meme.
Yeah.
Where are we going to put that?
I don't know. What data stores do you guys use? What's popular? No one's volunteering.
Well, look, Brad, I think we should go open source with this. I'll be honest.
Open source. Okay.
I think I've been using Mongo lately, and I think it's a good option for us.
MongoDB users? Any MongoDB in here? Yes, a couple. Okay, fantastic. Fine. I think probably we could get a few of the records, some metadata stored in MongoDB, running on a GCE instance. But now we just got to get started on this now if we're going to finish.
Wait, slow down, Brad. We've got to get this has got to be real world. People are using their mobile phones more and more, let's face it, all the time. And frankly, they're going to expect some kind of mobile interface.
Awesome. Well, I guess, he's running the demo. We got to do it. So we'll expose this as a set of REST endpoints and then consume it as an Android application so that you can view and create those memes on the client. So what we end up with is a very basic cloud meme application running on the phone, lets you view the memes and lets you go and create new ones. Actually, we're going to show you creating a brand new project for the Google Cloud Platform, set up your local workspace, and deploy that into the cloud. So you want to switch to the demo machine?
Sure, go ahead.
You want to switch to the demo machine?
So I'm going to start where everyone starts for Google products, cloud.google.com, and I'll go to the App Engine page first. And from there, we'll go ahead and try it now.
Yeah, so you go ahead and give that any name you want. Use your freedom there, Brian. So we're just titling this project, Cloud Meme back in. And then Brian's going to get to select whatever language he wants. I'm sort of a Java fan myself.
To be honest, I'm a fan of Python right now.
Python.
You should really go with Python.
It's a good thing. Come on, it'll never catch on. But I guess you've got the keyboard, so.
Well, look, Brad, we can even try it now.
Well, that's great. So you can interact with this sample right here in the browser. There's several for some popular Python frameworks. You can go make a change and then run it right here in the browser, and you can see your live changes come up. So this helps people that may be new to the platform. Okay, great. Help people that are new to the platform get started.
Absolutely. And look, the next step we're going to have to do is install our G-Cloud.
Yeah, so now we're going to provision Brian's machine here with the latest version of G-Cloud. We have a kernel-based install, so it's very easy to get up and going. And I think Brian's already got this installed.
I think I'll just leave the one I have.
Maybe we'll skip the install step. Or not.
No, we'll do it.
Apparently we'll go through the install. You can see it's asking Brian what languages he wants, so we can only bring down the components that really matter. And then we're bringing them down onto his machine and installing those. And you can see the set of components that we have here. So we now have a single unified installer for all the components that are in the Google Cloud Platform, so you can get up and running very quickly. What do you think?
And we'll get there, yeah.
We'll get there in just a minute. As soon as, yes. So how are you enjoying the day so far? Yeah, so we're done now. Okay, great. So Brian's just going to update a few install steps. Okay, now we have gcloud installed. So you probably saw in the keynote, but we can do a little playing with gcloud. So it's got some tab completion here.
All right, so I'll do gcloud, and I'll hit tab a couple times and see what my options are. And, well, let's look at the components. So I'll type that, double tab it, and I can complete my components. And I'll see what the options are for that. And as we saw in the keynote, you can actually list what components you have installed and what's available. All right,
yeah, so I think we're ready to initialize this project, aren't we?
Well, Brad, I think we need to authorize first.
Authorization, yes. So how hard is it to log in and give your credentials and whatnot?
Well,
yeah, so what Brian's going to do is actually use OAuth now to go and authenticate so that this instance of the SDK knows who he is on Google, so he can access all his Google accounts and whatnot for the cloud platform. Okay, so now I think we're ready to initialize. So we're going to do a gcloud init and use the project ID that Brian created earlier. And this is a brand new project, so there's no code in the repository, but if there were, it would sync that down. Either way, it's setting up his local instance. Okay, so I guess we're ready to get started writing some code.
We are.
So you have I guess the first step here is we're going to create a couple of REST endpoints. We're going to create one to list those meme templates that we have to base the memes on, one to create a new meme, to upload a new meme, and one to list all the finished memes.
So look, Brad, I think we need to start with writing those endpoints. So I'll drag over a file that I set up ahead of time.
Yeah, Julia Child style, I like it.
I go and open that up, and as you can see at the top there, we've got our standard imports for endpoints. Then we set up our client IDs for who can access it. And then you see a couple classes that we've got to wrap messages between the endpoints and the mobile client. So we've got one for memes, and we're storing the standard metadata, the image URL, the text, an ID to track it later, a user, and then it votes. And then we've also got a class to wrap that as a collection, and that's meme collection. And if we keep scrolling down the file, we see a standard endpoints definition. So we're defining our API. We've got cloud meme, we've got a version, a description, and then the allowed clients. So basically locking it down to our mobile client. And so we can walk through next from there into a couple of functions we created on our endpoint. Namely, the first one, create. We're going to expect to be able to create memes on this service.
Yeah, and notice this is an HTTP post, and you'll see in a minute you can just use curl to be able to access these, so these are standard REST interfaces.
And as you can see, we've stubbed it out, so we'll give it a response for our early testing. And the next one we can look at is listing. You're going to expect to list memes once you put them up. So we've got there, and you notice this one is a get. So you can do a standard get just to get a list of your memes. And we're returning a stored set of memes.
All right, yeah, that looks pretty good. I think we basically have the first part of the demo ready. Are we ready to just go ahead and push that up?
Well, let's go ahead and add it into our local repository first.
Of course.
And commit that.
So we're just committing it to the local repository on Brian's laptop. So now we're ready to push it up.
Look, Brad, I think we need to put some unit tests in.
Unit, you're such a Google engineer doing testing all the time. So I guess you already have those ready, prepared as well.
I have a few that I added in there.
All right. So we have some basic endpoints, and we have some tests written for those endpoints.
And look, Brad, we're going to need one more thing. If you want to make this an App Engine app,
we should make it an App Engine app.
YAML.
We should make it an App Engine app as well.
I'll go drag that in, and we take a quick look at it. And those familiar with App Engine, you can see we've set up our application. We've got a version, a runtime. There's settings in there. And then our handlers, we've set up our endpoints handler.
All right.
So
now Brian's just going to commit the app.yaml file and the test file to his local repository, and then we'll do a git push and push that up to the repository that the developer console has for us already. Okay, and so that's going to take just a minute to push up. So you want to flip over to the developer console?
Absolutely.
So as we saw earlier, you go to the developer tab there. Yeah, so as we saw earlier, we have a free private Git repository that's hosted for you that you can use. It's accessible to all the members of your team. And then, you know, of course, if you want to use GitHub, you can absolutely do that. And then after the push has happened as a post-commit action, we're going to run our Python unit test. You saw Brian add some unit tests. And the way we're going to do that is we have a virtual machine spun up, and it's already running Jenkins. And Jenkins is an open source workflow management tool that's pretty popular. And it's got plugins for everything. One of the plugins is to run Python unit tests. So you want to switch over and look at that VM?
Yeah, let's do that.
So that VM has been spun up, and you can see in a second probably the spikes where Brian has been practicing this demo. And what we're doing on this machine right now, we've already prepared it with or the cloud platform prepared it for us with Jenkins. And then when we did that push, it pulled the code down onto the VM, and it started executing all those unit tests. So at this point, we can see the progress on the unit tests and see how they're going.
Absolutely.
So if we switch it, yep, and the release history. So we should see an entry there for the unit tests. Yep, and you can see the tests have already done and deployed. But why don't we go ahead and look at the tests, though? So these are the test results page. So you can see here the list of all the tests and the runtime. Brian wrote some very efficient tests there, it looks like.
Stubbed out for now, yeah.
Yes, yes. OK, so there's the test results. So at this point, if there was a break in your test, you could use this to drill in and figure out what the issue was. So then if we go back to release, I guess we pushed it to production now, so we're ready to test that out.
It is deployed.
So, but remember what we built was a set of REST endpoints. So how are we going to interact with those REST endpoints and test them out to see if they're really working?
Well, we can use the API Explorer. So as you can see, with any app that you have, you can actually type in, use the specially defined URL to give you the Explorer.
Yeah, so _AH is the sort of magic system-provided URL space for App Engine, and then /API gets you into endpoints, and then /Explorer will bring you into this view with your own APIs set.
So as you can see, this is the API we defined, Cloud Meme API. And coming into there, we have the functions we defined on each of those.
Awesome.
So we can go ahead and test list, for example.
Yeah, and that's returning the hard-coded set that we have. Notice in the first box there, it's showing you exactly what the sort of curl command would be, what the HTTP GET is to be able to access this method, and then it shows you the response in JSON. So this is a nice debugging tool. It's a nice way to establish whose bug something is, if it's on the client or on the server. You know, if it works here, then it's not a server issue.
Yep. And we go back, we can even test our create. We stubbed that out as well. And inside the request body, you can add in the elements that we expect. So I'll put in a test URL, as well as some test text. And I can go ahead and execute that as well.
Oh, it looks like you got an error there.
We do need to authenticate.
Okay.
So we are going to ask our users to authenticate to create memes. So you can do that here by clicking on the button at the top and authorizing. And then we can go ahead and run that same query.
Yep, and notice here in the request, again, it shows you the metadata that you need to send up with the request to be authenticated. So again, if you wanted to try this, write your own lightweight wrapper for it, you could in JavaScript or whatnot. And then, of course, it shows you the results.
Absolutely.
OK, so I think we got the first step done, right?
We do.
OK, so let's switch back to the slides. So what we just showed you is that it's very easy to get started. We talked about using those standard tools. We showed you the simple build, test, and deploy, and how to test the service with API Explorer. Obviously, we only touched on this briefly. If you want to drill in more in this room, at 1 o'clock, there'll be a DevOps at Google that I encourage you to come to, where we'll drill into it in more detail. OK, we're ready for step 2. So Brian said we're going to build an Android app, so let's jump right into that. We're going to focus on 2 key pieces of that. One is we're going to build an Android-optimized Java client library for the services that you just saw. and we're going to show how to integrate that with Android Studio. So back to the demo machine.
All right, we're back in our directory that we added our files in, and we can run the endpoints command, get here. We'll get the client lib out of it. We'll give it Java. We'll give it our class name. And then we'll ask for it to give us a build system, and we'll use Maven.
Yeah, so what this is doing right now is it's taking the description of the service, the generic description of the service, and it's creating an Android-optimized Java client library for it. So that, as an Android developer, I want to interact with classes. Those entities should be classes, and the methods, the REST methods should actually be methods on a class on a request factory. And that's exactly what you're seeing here. All the entities Brian created earlier in Python, we now have Java versions of them. And then we have the Cloud Memes request as well. So now what's left to go, do you want to look at one of them?
Well,
yeah, Brian, let's look at one of them. That's fantastic. Yeah.
So as you can see, it's creating basically a model for you to wrap all the communication between the endpoint. And then if you come in here, you can see it's creating, for this one, we are looking at basically a Cloud Meme collection, and this is showing building a collection up of Cloud Memes. And standard getter and setter methods for it.
Yep, so this is going to handle all the authentication hassles, all the network plumbing, all the serialization and deserialization to JSON and back. So really, it makes this very simple to use.
And so the next step is going to be to basically install it on a Maven repository.
Yep.
Install it locally.
So because in just a minute we're going to access it from Android Studio uses Gradle as its build system, which knows how to speak to the local Maven repository. So to make that easy, we're going to put it into our local Maven repository here. So I think that didn't quite work there, Brian.
No, it did not. Make sure I'm in the right directory.
Okay, yes.
All right.
Okay, great, yes. So now he's got it in his local Maven repository. Now we're going to pop up Android Studio, right?
Absolutely.
So Android Studio is an IntelliJ-based IDE that we're moving to. It's a good option if you're an Android developer. And what we're going to do, actually, Brian already created most of the Android app. The boring bits of the Android app, all the UI, all the user interaction is already done. And what we're going to show now is how to access the service that we defined. So I guess the first thing you need to do is change the Gradle build file.
Absolutely. So we'll open that up. And we'll add in our dependency on the new Cloud Meme library. And we can go ahead and sync that.
Yeah, so again, Android Studio uses Gradle as its build system. You might recognize it's a Groovy-based build language. And that's really important for the flexibility that you need to build when you're building Android apps targeting multiple devices and whatnot. And what we've done here is just referenced that library that we just added to our Maven repository. Okay, so we've got the library. Now I see you've got the source code in there.
Yeah, so we'll open up our meme lister. We're going to have to list our memes. And then we'll go ahead and add in some additional code to access that new library.
Yeah, so now we're going to show the code that's actually required in order to call those methods.
So if we walk through this very quickly, we can see we're importing the Android app. You can see from here we're creating our service that we're going to use to communicate to the endpoint. At this point, we build it. And then for handling the intent, this is basically communicating with the UI layer. We can create our new meme. And then we can handle the create return back from the back end.
Okay, so that looks pretty good, right? We're ready to run it?
Let's do it.
So just to make it more fun, we've already got a version of the app running on this phone, so can we switch to the phone? So this is what the resulting app looks like going against those services. Notice we only have a couple of those stock memes that are there, but we have the basic UI functionality in place. We've got the meme there, and I can say, hi, boss, and I can go ahead and post that, and it's calling our service, but of course the service is stubbed out, so when we do the list again, we get the same static defined ones. But we have shown that we can build a basic Android application, and that it can call our services up there on the server. So, ready to, can we switch back to slides, please? Okay, so, right, what we just showed you was creating this strongly typed Java client library using the endpoints command. We talked about the Maven package management support and how to build the Android app. So at the end of the day today, or at 3:30 today, there'll be a whole talk just on building cloud backends for Android apps that will be right in here. So I encourage you to go to that if you want more info. Okay, we're ready for the next step. It's time to make this thing really production. It's sort of a toy app so far. We're ready to make it real. To make it real, we're going to do two things. We're going to store that image data. We're going to store it in Google Cloud Storage, in our blob storage, our bucket storage there. And we're going to spin up a MongoDB cluster and store the metadata for those images in that cluster. Okay, Brian, are we ready to roll on that? Okay, let's switch back to Brian's demo machine.
So if we're going to add in the next service, we're going to go back to our files, and we've prepped a few more to accomplish this. I think the first thing we'll do is actually add in our cloud storage and our image generation. And if we pop open the cloud storage, take a quick look at that, you can see we're importing our cloud storage Python library, which is, again, is a Google-provided library, setting up a URL for our memes to be at. Coming into our upload method, we can see we're defining a unique ID, assigning it a file name that we're going to upload to cloud storage. And in the middle of the file, we're creating our cloud file on cloud storage, putting in settings there for writing a file that it's going to be a PNG image, and then it's public readable. And then from there, we're basically writing out the binary image that we pass into this function into that cloud storage file. And then the last step is actually writing it out to cloud storage.
Yeah, that looks pretty easy. So again, what Brian's showing you here is code that's running on App Engine that's taking the image and stitching it together, putting the text on it, and then storing that off to cloud storage. So you want to show it in cloud storage?
Yeah,
show the cloud storage viewer?
So if we come into the developer console and you're on your application, you can click down on cloud storage and you get to your browser. As you can see, we've set up some buckets for use. Cloud meme bucket is the one we'll be writing to.
And it's not really in Spanish, though, is it?
It's not in Spanish, no. And as you can see, we've actually been doing a bit of testing, so we've got some memes in here already. And again, this is all going to be accessed from your application, both writing and reading.
Okay, so that looks great. So that's the basic story for storing memes in cloud storage, storing the image data in cloud storage. The next step we need to do is store the metadata. That is the text description, so we can do searches on it, the who uploaded the meme, and other metadata. So in order to do that, we need to create a MongoDB cluster, don't we?
Let's do that.
So we're actually going to use Cloud Deployment Manager, which you'll hear about a little bit later, but it's a way to deploy software onto Compute Engine instances. And we're going to spin up several nodes of MongoDB and configure them for us to use.
Absolutely. So basically on this page, we have a way to deploy MongoDB in a size cluster. So basically we set up a replica name, you can choose a zone, choose a network to deploy it to, give it a prefix, and then actually choose the count you want to deploy of nodes, as well as set up your disk sizes and your arbitrary.
Yeah, and you can just hit deploy cluster there. That's going to take a few minutes to deploy, so we already actually have a MongoDB cluster that we deployed earlier, so we're going to switch over to use that. But this is a great way if you want to experiment with the platform, do some performance testing on it, do some capability testing. This is an easy way for you to go put some open source packages up there and see how they perform for you. And of course, all this is being deployed on virtual machines that you own, that you can go and SSH into, control however you want. So they're fully yours.
So look, the next thing we'll do is actually add in the connector for the Mongo. So I've got a little code I prepped ahead of time. So we'll go ahead and cut and paste that back into our API file. And as you can see, for the import, we're inputting our pymongo library. We're setting up our Mongo connect string. If you're familiar with Mongo, you'll recognize the user, password IP, and then the database.
We got to remember to change that password after this.
We'll definitely change that password. And from there, we can add in, actually, first add in our create. So we've got a create function here. So we'll scroll down to create. And we'll create, basically pasting our create there. And then we'll also have a way to list our memes, get the metadata back from Mongo. So we'll go ahead and take that and paste that in, replacing our stubbed implementation. And then we forgot to do one more thing. So I'll scroll up. We did forget to put in the code for our cloud storage connector, so we'll go ahead and add that in as well. So we'll add in our imports for cloud storage.
Those are handy comments you have there. It's very helpful.
And the bucket. And then we'll go ahead and add in the code to create the meme as well as upload it to cloud storage. So back into our create and replace our stubbed implementation. And now we're ready to create it in the cloud.
Okay. So now what we have is code that can store images in cloud storage and store the metadata into MongoDB. And then when we do the listing, it pulls the image URL out of cloud storage and pulls the metadata out of MongoDB and returns that back to the client, all over REST endpoints.
And so to make this happen, we've got a few libraries we need to install as well.
Right.
Just standard libraries. So we'll drag those all in, go back to our console, add the stuff we just committed to the local repo. Mongo.
Okay, so this is going to take just a minute. Brian's going to commit it to his local repository, and then he's going to do a git push and deploy it up to the App Engine app. Now, what's going to happen on the App Engine app is we're going to sync down all the source code that he just created, including his unit tests, onto that Compute Engine instance. And then we're going to use Jenkins to orchestrate a workflow that has us doing tests, running all of his unit tests across those. And then when those unit tests are done, go ahead and push that out into production. Now, all that's going to take a couple of minutes. So in the meantime, let's look at the release history, and maybe we can look at the diffs between releases.
Absolutely.
So one of the things that is very cool is that we actually roll up all the release diffs into a single view. So imagine you have a production issue and you're debugging it. You want to know what code changes went in this last time. So if we do that, we see this diff view here. Notice there's two different changes that went in, both done by Brian, but in a big project you might have them done by several people. And then we can kind of get a sense for what changed at this particular release. So just click on one of them and let's see. Click on a more interesting one.
Okay.
Not that one, any one but that one. Okay, well, all of them are starting from blank. Is that basically the deal?
Yeah.
Okay, yeah. So anyway, it would show you exactly what the changes are. So now, should we go over and see what our progress is?
I just realized we did forget one more thing.
Oh my goodness,
we're in our
one more thing.
YAML, and we just want to make sure that we update this to the latest version. So
okay.
I'm going to make a change.
Yes, the demo version.
To the real version, yeah. Call it Demo 1 for now.
Okay, yep, so you're seeing the real thing. So now we get to go deploy it again. And now what will happen now is if it's not done with the build and test when a new one comes in, it actually scraps that one and starts over with the new one. So it doesn't wait for the first one to finish, because we notice this kind of thing happens. Right at the last minute you figure you missed something, so there's no point in finishing the build on the other one if there's a new one right behind.
And so you can see we've come to our source. We see that our source repository has already been updated. And then right now it's pushing it out, putting it into pushing into Jenkins, doing the unit tests.
So you want to see if it's...
Let's see if it's reached the test now.
So the way this works is this line is actually written as soon as the unit tests start to run, in the case of Python, or in the case of Java, as soon as the build starts. So is it there?
It's there.
Okay, great. Yeah, fantastic. Oh, and it already deployed.
It's a deploy, yeah.
Awesome. So we're ready to test it out. So you want to test it out in API Explorer?
Absolutely. All right, so we can come back into our API Explorer, just refresh. We see our methods we had before. They're no longer stubbed out, so we'll go ahead and do our list.
Yeah, and so this list at this point is, we have a great server error there.
Well, look, I'll make sure we're on the right version now.
Okay, so what Brian's going to do now, so App Engine actually supports having multiple versions of your application running in production at the same time. And that's useful for doing things like A/B testing. It's useful when you're staging out a release. Maybe you want to have it only accessible to a few people and then roll it out to be the main version.
So we'll go ahead and do a list on that.
And now, okay, now we got them. And look, those are real. So that's pulling this metadata directly out of MongoDB. So the MongoDB instance running on GCE, pulling that data through to App Engine, and then it sends it out, serializes it to this JSON interface.
And we'll go ahead and list, we have a set of templates that we can build from, so we'll go ahead and list those.
And you can maybe grab one of those URLs.
I'll grab that top URL there.
And then my favorite thing, you can go in and actually post a new meme. And this time when he posts a meme, it will actually create that meme, store the meme in cloud storage, and store the metadata in MongoDB.
And then we'll make sure we auth before we send that on.
Ah, yes.
And we'll
Just see if that, yes, fantastic. Okay, so it looks like it worked. Did it create the meme?
It did.
So what Urs says goes. Okay, so now what we want to do, can we switch over to the mobile device? And you see, I just refreshed this right now as they were coming, and the very first meme is the one he created, what Urs says goes. So pretty cool, huh? And of course, I can do the same thing. I can say, oh, whoops. Yes, boss. Whoops. And I can go ahead and post that. And now I'm posting it from the Android device. It's going up through the App Engine endpoint, storing the image in cloud storage, the metadata in MongoDB, and then returning all the results back down to the device. So that's pretty neat. Okay. So are we ready to switch back to slides?
Yeah, slide.
Okay, so let's go back to slides. So did we do this one? Yes. No, we didn't do this one. Okay, so what we just showed you was the cloud storage MongoDB thing. I mentioned MongoDB uses Google Deployment Manager, and you saw some of the replica pool stuff Brian just touched on a little bit. There's a whole session on that at 1 o'clock upstairs that you can go and drill in and learn more about that. And I know some of these sessions conflict in time. All this is being preserved on the internets forever, so you can go watch these at your leisure later. Okay, so that's step 3. But you know, I'm not really satisfied yet, Brian. I mean, we got a working application, but we haven't really proven to these people that it can scale yet. So I think we should show that. So we're going to show some very simple load testing. And then we're going to use that load testing to isolate an issue in production. And then show you how we can fix that issue in production very quickly. Okay, you want to take it away? Back to the demo machine? Are we good?
Yeah. All right, so we're going to basically kick off a load test, and we'll just use Apache Bench as we're using in the keynote. But for this one, we're going to throw a little bit more at it. So I'm going to say throw 1 billion rows.
I don't know, 1 billion, that's pretty good.
Yeah, well, maybe we'll go, I don't know, 200 concurrent. And then we'll give a URL we can hit.
So Brian defined a special endpoint for create that just tests out storing a particular image to cloud storage and storing some metadata to MongoDB. And so hitting this 1 million times, 200 at the 200 simultaneous, is going to give us a pretty decent QPS, queries per second or requests per second. At Google, everything is queries, so we call them queries per second. So we're hitting that, and now we're going back to the developer console here, and you can see some of the graphs are starting to notice the increased load there. And I notice, Brian, these errors by status code. Just scroll down a little bit. We're starting to see, or at least last time you did the demo, we saw
we do have a few spikes coming up, yeah.
A few spikes. There's a little latency in the graphs, so we'll see a spike in 500s in a minute. So why don't we switch over to the logs viewer and see if we can find out why we're seeing those log errors. So So again here, what we're seeing is all those requests are coming in, and each request from whatever front end, I think we said we had 5 or 10 front ends running right now. There's about 5 front ends running right now, and we're aggregating logs from all those front ends and putting them here. Every create is creating a log entry. And you notice some of them are actually 500s. So you're going to filter down to find just those 500s. So those are troubling. That means we actually have an issue in production, and it seems to be happening for only some requests. So we need to debug this and figure out what's happening.
Well, it looks like there's an exception, Brad.
There's an exception, so it's bad.
Let's track that down, and we can click down in the file.
Yeah, so in the keynote, we showed you that in Java, and here we're showing you it in Python. So the same basic infrastructure works no matter what language you use.
And as you see, it dropped us into the file and highlighted the line that's causing the problem.
Yes. I think that random 5 is probably the source of your...
It looks a little bit manufactured.
Yeah, it looks a little bit of an issue. So again, at this point, because it's in a Git repository, we could go back to the local machine and fix this issue. But because it seems like a pretty obvious fix, I think, Brian's just going to click on Edit here and go ahead and remove this erroneous change. And then he's going to commit that back to his production Git repository. And so you should probably have this down by now, what's going to happen when he clicks commit, right? So it's going to put that change in the Google hosted repository. And then it's going to sync down the code into the Compute Engine virtual machine that's running Jenkins on there. And then that Jenkins workflow is going to kick in, and it's going to run all our unit tests across there. And given that those pass, hopefully, we'll deploy that out into production. So that might take just a minute for it to deploy out to production. Okay, so yeah, so what we're showing you here is that it's already deployed, it's already run all our tests, and it just finished deploying to production. So now, if we go back to the logs viewer, we should see a beautiful lack of 500s. If we are successful here, as he scrolls down, remember we're still hitting this site with 1 billion requests, right? So it's going to take a while to get through those. And now we don't see any 500s. So I think our logs are clean. That's pretty good, Brian. Thanks, man. That's good. All right. Cool. Okay, so back to slides, and let's wrap us up here. So what we showed you in this part is we showed some basic load testing with Apache Bench. We showed you how to do some debugging in production and how to fix that production issue. So if you want to hear more about how some of this works under the covers, what's really going on, at 2 o'clock there'll be a scene inside your service session. That's a good one for you to check out. Okay, so wow, we did a bunch here, Brian. Like, we started absolutely from scratch. We built a real-world Android application. It had MongoDB and Google Cloud Storage in it, and then we showed the whole DevOps workflow here. So that's pretty good for 50 minutes, don't you think?
Not bad. Yeah.
I have a hunch there might be a few people that want the source code for what you just did, and Brian will post that shortly up on his GitHub repository, so you can go and check that out. And then a lot of what we've shown is already available to you in the Cloud Console, but there's a few things that were not quite ready. So if you want to get Trusted Tester access, there's a form you can fill out there. All of it will be ready in the next few weeks, but if you just can't wait and you need the linking logs to source or some of the other features, you can fill out this form and get access to that. So thank you very much.
Thank you.
And we have a couple minutes for questions, I think. So any questions for us? Anyone? Yes, right here. Yeah, so the question was about A/B testing and staged rollouts. So we don't have any built-in support for that right now, but it's absolutely something that's on our roadmap to go do. Yes? Yeah, so the question was in performance between cloud endpoints on Android and just like an HTTP library. I think you'll find they're very similar because you saw the REST requests that we were showing. You can hit those with curl. There's very little extra metadata that we're sending down for cloud endpoints. So I suggest you go do some perf testing, but it should be pretty close. Okay. Oh, and there's a mic. Fantastic.
Hello? Hello?
I can repeat. I can repeat. Go ahead. Yeah. Yes.
So something we're looking at. Today we're looking at purely a launch. Once you get it launched, you can manage it yourself. But ongoing, we'll look at additional tools we can provide.
Yeah, but I mean, Brian, when we were building this demo, very regularly went to the Mongo. In fact, can you bring it up? Can you bring up the Mongo admin console? Absolutely. So it's just installing Mongo on a GCE image. So all the existing MongoDB admin tools work. So we haven't done anything special. What Brian's mentioning, we haven't integrated the MongoDB admin UI into our developer console, but you can just hit the right URLs, right?
No.
Not yet.
Well, not yet. Not
soon.
Yet. Something we're
soon.
working on.
Soon. Okay. Coming soon. Okay. Yes.
Any planned languages coming up?
Planned languages. So there is a session. There is a session called something like New Languages in App Engine that I encourage you to go to. Okay, so I think we're just about out of time. This is the only thing separating you from lunch. So Brian and I will be up here for a few more minutes, so feel free to come grab us if you have more questions. Thank you.
Thank you.
We don't have that? Huh? We don't have that?
One, two, 1, 2.
welcome back. It's always hard to be the session right after lunch. How was food? Was it good? Google is known for good food, so. Did you eat too much, so now you're a little sleepy? I hope not. Well, actually, I'm not worried, because what we're going to talk about is going to be really exciting and close and dear to your heart, DevOps. So we're going to be able to have you engaged for the next hour. We're going to talk about how to not only write code, but also ship it into production, maintain your life site, and troubleshoot and debug successfully. I'm Ray Wang. I'm a product manager on the Google Cloud Developer Experience team, and I have here with me Chris Smith, who is a tech lead on the team and my demo buddy today. Okay, slides. Okay, I used to work on the back end of a large-scale service. It was really exciting, the kind of problems you get only when the scale is large, and the number of customers you get an impact. But it was also frustrating. We had a lot of really good ideas. We wanted to launch a new app and add features and impact customers. But in the end, the time that we got to spend on writing code was about less than half the time. So what we do? Review and testing and push out these large-scale code changes and massive refactorings have enabled us to increase our velocity. And we get that benefit with a single code tree. Fast access means that engineers can answer all kinds of interesting questions about the code. Who's using my API? What's this library? Look for another piece of code. And merging early and often enables us to do easy rollback when things go wrong, right? And we know we're going to break things. So we need to make sure we can roll back safely. Having the code be open means that we can help each other out. We can help fix bugs, right? An issue comes up, we can bring together the right people to get it fixed. And quality is very important to us. So we do have mandatory code review by experts and our code developers. So I'm going to take a pause there for a second and ask you, how many builds do you think Google does in a day? Audience participation. How many? Millions. Okay, how many tests? One build. That's a good one. How many tests? Anyone? Bueller? As many as builds. Okay. All right, well, here's some of the stats that we're talking about. So around 800,000 builds a day, leading to 2 petabytes of build output. 25,000 change lists in a day, with per minute ranging from 20 plus per minute to 60 plus per minute at peak. So the tooling that we've built at Google, really, the whole focus is to enable velocity, and speed and scale are critical for us. So working at speed and scale, it's a challenge, and the engineers we keep raising the bar for ourselves, right? But what's it like? What's the culture like? And I just wanted to point out a couple of things, right? This idea of having the code base be open, collaboration and code development are key, right? With this accountability to help each other fix issues. Sharing code across products means that engineers don't have to write code that already exists, right? We have common libraries and common services and different pieces that we can reuse, and that leads to velocity. And engineers have autonomy, right? Engineers can make their own choices around what makes them productive. So how many Emacs users? Audience participation? Okay. All right. How about Eclipse? All right. Okay, how about, dare I say, VI? VI. Yeah, there we go. Okay. Right? So we know that we need to offer a variety of tools and options so that engineers have this choice to pick what works for them. And near and dear to my heart, as an engineering team building tools and infrastructure for other engineers, we need to make sure it makes us productive, right? We use it ourselves. We do this thing called dog fooding, right? Where we make sure that it works before sending it out to our users. So I don't know if you can tell, I'm a little proud of what we've built internally. I'm a little proud of it. And it sounds pretty good, right? Pretty good, pretty good, okay. Well, we struggle.
And not to air any dirty laundry here, but I will. It's never fast enough. Every single engineer that I talk to, it's not fast enough, right? The build is too slow. Engineers want and expect almost instantaneous results for what's broken, right? What test is broken, so they can fix it, right? So we can get features out to our users. The rate of change is so fast, right? It's hard to keep up sometimes. So if you have dependencies in storage, right, or in certain other areas of the stack, it's frustrating when things break, right? It can slow us down. And that's something that we're working on. Quality processes, very important to us. They help us a lot. Sometimes they slow us down. It takes too long to turn things around, right? And we want to keep this focus on automation and velocity for engineers. And finally, I just want to highlight that finding and fixing bugs, it's tough for us too, right? I need to go look at this log file and this log file, and I got an alert. I'm not sure that's related, and I need to figure out what needs to be monitored. So there's a session right after this to talk about the insight we want to give you into your service. But I just want to acknowledge that this is something that we struggle with, and we want to make it better for everyone. So we think you deserve better, right? As you heard Urs say today, right, we're not keeping any of these tools to ourselves. So whether you're Gmail or Snapchat, we're going to focus on making the best platform that everyone can build on. And I'm really excited about the opportunity to take the experience, knowledge, and tools that we have internally and offer these to you. We want to develop a community, right, for third parties. It's easy for third parties and developers to plug in functionality, to innovate in new markets and tools, and to raise the overall value of the ecosystem, right, to make it better for all of us. So with that, I'm going to turn it over to Ray and Chris to talk about the specifics of what we're going to launch: productive developer tooling, continuous delivery system, and better DevOps. Thanks so much for being here today.
Wow, the audio. So as we just heard from Melody, that DevOps is hard for everyone. It's hard at Google too. Regardless of whether it's making 100,000 builds at Google or it's your own company making 3 builds a day, it's hard, it's time consuming. Developers all need support from great platform to be productive and innovative. So that's why we have started now building these DevOps tools, not only for Google developers, but more importantly for you, the Google Cloud customers. Let's dive into them. First, I want to talk about code. The soul of the application lies in the code you write. So you need a great experience working on your code on the cloud. We did a lot of user research study. That's when we go out and talk to many developers and actually sit there for hours and watch how you work. And we learned there are a few things that your favorite IDEs don't do for you yet. First of all, how many of you only work from a single desktop all the time? One? OK. No laptops, no phone, no tablets? So these days, a lot of applications need to be up 24/7. But we can't be chained to our desk for that long, right? You have a life, you're on the go. Luckily, you have devices. And your code needs to be accessible from where you are. The other thing we observed was that many of you need to switch between multiple windows to get your work done. Because it's not just your code. You also want to look at logs and traces and metrics and analytics. The big dual monitor with 8 screens that gets your eyes busy all the time, that probably looks cool, and it's probably how Hollywood wants to think about it. But you know and I know that's not good for your productivity. The context switching slows you down. So the ideal cloud should offer you easy access to that entire stack of data, put in the context that you want. We don't like it when things go wrong. We really don't like it, but it's life and it happens. Today, when stuff goes wrong, it's often really difficult to find the culprit code, because just think about how you do that. First, you have to figure out which releases have been deployed to which environment, at what time, by who, right? And then you have to chase down which code commits went into these releases. We think a powerful diffing tool should easily help you answer the question of what has changed without requiring you to manually look into these different sources of data. So now let's see the real thing. Chris is going to show us some demos of the features we built to solve these problems.
All right, thanks, Ray. All right. Could we cut over to the laptop, please? All right, so hello, I'm Chris Smith. I'm a tech lead on the team here, and I'm very excited about developer tools and tooling and being more productive. But I'm going to let you in on a secret today, and that's my first love is game development, which is why I am super stoked today to launch my brand new, super exciting, original IP, Fluttery Bird. Now, of course, right? Yeah! Now, this may look like a cheap knockoff of Flappy Bird, and it may seem like a cheap knockoff of Flappy Bird, but I assure you it's super awesome and a lot of fun. In honesty, I can't take credit for it. This is a clone of Clumsy Bird, which is also a clone of Flappy Bird. It's clones all the way down. But what I have done is added a backend using Google App Engine to keep track of a worldwide leaderboard. I just scored 2 points, and now if I go to this high scores page, I can see those 2 points. Now I see a few of you maybe in the audience trying to play along, and I don't see these other scores even if I refresh because there's a bug here. You see earlier, today I got a text message from a friend like, hey, my scores aren't showing up, what's the deal? And we can verify this very quick by just going to in an incognito window, playing real quick, scoring a point, and then verifying that, alas, the score isn't being uploaded. So there's a problem here with my production app and on the launch day of Fluttery Bird. So what am I going to do? I'm going to fix this by using all the DevOps tools that we've built inside of the Google Developers Console. So I'm going to quickly load it up, jump to my project, and the first thing I'd like to show you is the release history page. Open up Cloud Development and Release History, and this is showing me all the deployments of my application, Flappy Bird. Something I'd like to bring your attention to is the changes column. So here's a deployment where I fixed the high score sorting. If I open up the diffs page, it will show me all the commits that were included with this deployment. That is all the changes that were made, and as well as showing me the diffs inline so I can quickly scan what's happened to my application. So using this feature, if I go back, I could probably get a sense on what the problem was from this dubious refactor user service change. But I don't want to give away all my secrets. So another way to debug or troubleshoot this app is to just go straight to the logs. Loading up the new App Engine Logs viewer, I can filter this by error and scroll the way down, and sure enough, I see some errors uploading high scores. Error uploading high score, non-admin user attempting to upload a high score. Well, that doesn't sound right. I mean, sure, as an admin, I can upload high scores, but I imagine that other people would want to use this high score leaderboard as well. Okay, so what I'm about to show you may be the greatest developer feature ever in the history of mankind. Quick question, right? Quick question. Why is this that weird shade of blue? In fact, if I hover my mouse over highscoreservice.java, that gets underlined for some reason. It's exactly what you think it is. It's a link, a hyperlink, boom, from the runtime error logs directly to your source code. Not only just some random file, but the specific commit and the specific line where that error occurred. So going straight from the App Engine logs, I can jump right to the problem, where it occurred in my code, and sure enough, some bonehead developer on the team, this guy, introduced a problem. So what I'm going to do now is, I guess, drive to the office, go to my desktop, make the change, commit it, et cetera, or right here on stage from my web browser, or maybe my tablet, or possibly even a phone, I can just click Edit. I'm going to make this change, just comment out this piece of code, and then I'm going to commit it all from my browser. All right, and this is going to commit
But not only that, it's then going to build my application, run its unit tests, and once everything's green, deploy Fluttery Bird worldwide, fixing the problem and saving the day. I'll talk more about our release and deployment tools in a minute, but for now, I'd like to give it back to Ray.
Okay, now that Mike's on, I just want to say again, go Fluttery Bird. So now let's look at a recap of the features that you just saw in the demo. And by the way, all the features you just saw will be coming to you in the next few weeks. To help you to easily work with your code in the cloud, we're offering you Google-hosted Git repos. And you also saw the browser-based file viewer and code editor. And not only that, the ability to check in your code right from there, where your code is. To help bring together your code and the runtime data, we're offering you log-to-source linking. That's when you can go directly from the message in your log file into the code that caused the error. And that's just a first step. We know that logs are not the only thing you look at. They're also monitoring metrics, other analytics data. And we're thinking about bringing all of them here so that your code can become the canvas on which you can display and analyze your application's performance data. To help you answer the question of what has changed, we're giving you not only code diff, that's normal, everybody does that, but more importantly, deployment diff. So you can easily tell the delta that has happened between two deployments. So now you have your code. What do you do when you have your code after code is done? You don't just keep it sitting around in your repo, right? You want to deploy it. That's when it becomes real. So let's talk about deployments. Deployment is the lifeblood to your application. Deployment time is just about the most exciting time because that's when all your hard work pays off, right? That's when your app hits the market, customers start using it, that's when you become a hero. But it's also a very scary time. That just tends to be when things go wrong. How many of you have had outages right when you deploy the new version of an app? Happens, right? You're with me there. So you definitely want your deployments to be reliable. That's the most important thing. You want to have the confidence that whatever you're deploying to your production does not have a critical bug in it. And you certainly don't want to be the one paged at 2 o'clock in the morning because you just brought down the app. You want your deployments to be fast. You don't want to wait for hours or days for your work to hit live site to be used by customers. You want that to happen in a matter of minutes. The other thing that fast deployments do for you is if you can deploy and release fast, then you can end up doing many frequent, smaller releases. Now, why is that good for you? Let's just imagine if you're sending a release that contains 100 code changes into production. Something goes wrong. What do? Right, you have to roll back that entire package and then take it apart, out of the 100 changes, find the one that's the issue, cherry pick it out, put the 99 back together, send it to production, and hope that you got the right one. But if you can do fast and more frequent and smaller releases, if your release only contains 1 or 2 code changes, things go wrong, roll back and you're done, right? And we don't like slow deployments. We want them to be fast. But there's one thing that can be even worse than slow deployments. That's not knowing where your changes are. Have you had that happen to you? We all know what that's like, right? Your changes need to be visible and predictable. When I used to run deployment for a pretty big backend, I found half of my job became answering exactly 3 questions. Where are my changes? When are they going to get to production? And what has been deployed to this environment? So after a while, I learned to make myself more productive. I set up an auto-response message with some of the answers in that. That made the line outside of my office a little shorter. It shouldn't be that hard. You shouldn't need a crystal ball just to tell when your changes will get to production. And we certainly don't want you to keep pestering your release managers. And last but not least, we know there are great best practices that have been proven, and you can use tools to adapt them. But at the end of the day, every person and every team is different. You might want to build and test differently than all the other developers. And you want to decide what environments you want to use. You might have specific approval policies that you need to put into place. And we want to support you there. We want to meet you where you are. Now it's exciting demo time again. Chris, come on stage.
Thanks, Ray. All right, so we use this push to deploy feature to roll out the fix to Flutterybird, therefore saving the day. I see somebody who's tried to play it on their laptop, and evidently that hasn't fixed or fixed the issue, and we'll see what the deal is. But first, let me explain a little bit of how this is all happening. You see, last summer we initially launched push to deploy. That is a Git source code repo that whenever you make a commit to, it automatically deploys it to App Engine. This is an alternative to using the App Engine SDK and deploying manually. And it's a way to be more productive if you're using Python or PHP, languages that don't require a build. But if you want to use Java, or if you want to run some unit tests before you deploy your application, well, then you would be out of luck. So that's why this quarter we've launched push to deploy plus build. If I go to the Releases tab and under Configuration, you'll be able to see the different kinds of releases. Not only is there vanilla push to deploy or push to deploy classic, but also offering a build machine for Java Maven-based builds, Java using the Gradle build system, or Python with nose tests, PHP with PHP unit tests. And I want to spend a couple of minutes explaining part of the technology on how this works. So whenever you make a commit to a push-to-deploy enabled repo, if it requires a build or test, we'll provision a Google Compute Engine virtual machine for your source code to do the build and the test. Normally this happens on demand, but I've modified this project so that it's still running so I can show it to you. If in the developer console I quickly refresh this page, and it will show a Compute Engine VM that is running the actual build machine. In fact, if you look over the past day, each spike in CPU utilization is when I've triggered a build. And so this is the actual machine, and you may be wondering, so what's actually doing the build? Is it a shell script? Is it some Google specialized build farm or whatnot? Well, let's find out. If I open up that port 8080 on that machine, it's going to show me the man behind the curtain, which is Jenkins, an open source continuous integration service. Quick show of hands, how many people here have heard of Jenkins, used Jenkins? Oh, wow. Okay, so many of you. Hopefully you're not familiar with, or you're familiar with Jenkins. Well, this is the job that we've created on this machine, aptly titled, My Job. I can go to the configuration of this job, and I'm just going to quickly scan over all the various things that we've set up. First, we do the build, upload the results, run the tests, push to App Engine, the standard sort of fare that you would expect. Now, there's a key point I'd like to highlight here, which is that we're using the Google Cloud Platform to build tools for the Google Cloud Platform. Not only using Compute Engine for the build machine, but we're also taking advantage of Google Cloud Storage. If I go over to the Cloud Storage tab, you can see that we create a push-to-deploy bucket. This bucket stores the results, build results, test results, and metadata for each deployment that it does. So these folder names, these are the Git caches that are being used. And if I open up one of these, you can see the raw build log that is the output from Jenkins, the test results, as well as the actual payload that we've deployed. In fact, we use the metadata for this object to power information on the release history page. So I'm going to go to that real quick so I can show you how flawlessly the system has worked. We issued the commit through the web browser, did the build, ran the test, deployed it, made Flutterybird a worldwide success, or it has failed because the tests have failed. I'm gonna pretend like I'm surprised, but I've been working on this demo for weeks, so don't worry. I can drill into the tests, see these are the operations that the build machine has performed, but of course the tests have failed. So still within the Google Developer Console, I can drill into that and see, well, what actually occurred. So it turns out some of the tests passed, but the high score service did not throw an exception. Just love it when you have these sorts of bugs. You have some bad logic in your program, so you remove it, and then you introduce a new bug, which is the unit test that expected that bad logic now failed. You can't win them all. Well, next I'm going to show you using the G-Cloud SDK and going to the command line and just fixing this using my existing Git and tools and my existing workflow. But before I do that, I want to show you one more thing, which is going back to the Google repo. It's great that Google has a Git source code repo that will enable you to do this push to deploy and build experience. But how many people here aren't already using Google for their Git hosting, or maybe using Bitbucket or GitHub? You know, how many people here use GitHub? All right, similar to Jenkins, most of you, which is great. Well, we've launched a feature called connected repos. That is a way to mirror an existing GitHub repo and have that transparently and seamlessly work with the tooling that we've provided. So you can use your Git repo just like you do today, but whenever you do a push, without needing to configure the remotes manually, it will just automatically trigger these sorts of workflows. So to give you an example, I have a connected repo, the App Engine Python Hello World, and I'm going to use the GitHub-based editor to just change it. It prints Hello World and the word orange. Why don't we change that to Apple? Oh, I guess first, this is the current state of the application. Swift Catfish 511. You can see it prints orange, just so you know. But I'm going to change that to Apple, scroll down, and all right. And then I'm going to make this commit directly in GitHub. But you could imagine this is you pushing to your Git repository like you also do. Shortly, this is going to trigger the push to deploy experience that we've expected, and then we'll hit refresh on Swift Catfish 511, and it will print the word Apple. But first, let me hand it back to Ray.
Thank you, Chris. And can we go back to the slides, please? I want to show you again the flow of the demo that you just saw. You can make a code commit from into either the Google hosted Git repo or your own GitHub repo, so nothing needs to change. Just use the same commands that you used today. The commit triggers push to deploy, which then in turn invokes Jenkins to run through the build, test, and deploy steps for your application. The status results are displayed through UI and CLI, and we also preserve high-fidelity logs and put them into your Google Cloud Storage bucket. So these are the features that you just saw. We know that to help your releases and deployments to be fast and reliable, automation is the best way. There are some things that machines just do better than us, right? Such as repetitive release tasks, so let's dedicate to them. For that, we have launched Push to Deploy to automate the build, test, deploy steps for you. But we also know that many of you need to use a number of different environments before your code hits production to validate that it's working correctly. Having to push to individual environment is a hassle, so we are now working on expanding this to a full multi-stage pipeline with permission and quality gates between them. To give you visibility into your deployments, our UI and CLI tools offer you notifications, statuses, standard outs, a history of all your past builds and deployments, but more importantly, linking them back into your code commits. To meet you where you are and help you to customize how to do your releases, we have built Push to Deploy on top of Jenkins that so many of you already use and are already familiar with. I just want to emphasize that we take the hard work of hosting Jenkins, so you don't have to worry about setting up, monitoring, maintenance, all that annoying stuff. It's on us. So you can focus on the more important stuff, which is your application. In the current version of Push to Deploy, you can select which language your application wants to use, which in turn selects the number of tasks to run through for Push to Deploy. And going forward, we want to make this a more open platform, so you can specify your configurations, customize your build and test parameters, and even bring your own Jenkins plugin. So that was deployment, and that was code. We saw lots of great features in the UI in the Google console. But I do know for some of you that command line is what you want to use on a daily basis. So who are here with me, command line users? Yeah, a lot of you, right? So you're going to love it. Next, let's talk about the Google Cloud SDK and command line tools. So when we think about command line, we think of fast and light ways to do things. And therefore, everything around the command line tool should be fast and easy. And that means it's easy to set up, it's easy to maintain for any environment you're working and for any member of your development team. It should also be easy to learn, to ramp up, to use, especially if you already use our UI or API, learning command line should be straightforward. And if command line is how you want to do things, it should not only work for 1 or 2 commands. It really should be available for all the things you want to do on Google Cloud. So now we're going to go back to demos, and Chris is going to fix his unit test.
All right, thanks, Ray. Let me log in quickly. OK, so just to keep me honest about the GitHub connected repos, I'm going to refresh Swift Catfish. Just like we expected, the Git push was all the way through our system and deployed. All right, so let's go back to Fluttery Bird, the world's greatest app, I might add. So we have a problem. The build works, but we need to fix this unit test. So again, what's the quickest way to do that? Well, I showed you the web-based editor. Now I'll show you the G-Cloud SDK. So I can do this on the command line. So you've probably seen this before, but how do you install the G-Cloud SDK? Here's a quick cheat sheet. Curl, crazy long URL, pipe to bash. That's all you need. All right, I've already installed the G-Cloud SDK on this machine, so if I wanted to know how to use it, I could just type help, okay? And that will list all the things that I can do and sprockets, but I'd like to remind you all of something. It is the year 2014. We live in the future, and although we don't have flying cars yet, I think we can expect a few other nice features from our tools. So I'm just going to type G-Cloud and press tab twice, and now we finally have auto-completion right in our console. So if I want to know what I can do with the components that I have installed from the G-Cloud SDK, G-Cloud comp, tab will autocomplete the components, and those are the operations. And then finally, G-Cloud. And I can list all the things that I have installed. OK. So great. Well, one problem that you'll always run into when you're using command line tools, such as the current generation of or the previous generation of the App Engine SDK, is how do you authenticate yourself? Well, you could break your flow and just have to type in your password every few minutes. Or you could set up an application-specific password, but there's some security concerns there. Or you could use OAuth, and that's great, but then you have to authorize it for every single different resource, for using GCUtil, for pushing to App Engine, maybe cloud storage as well. Well, I'm happy to talk about how the G-Cloud SDK has solved that with one command. If I want to authenticate and log in with all my command line tools as me, all I need to type is G-Cloud auth login. This is going to take me through a single OAuth flow so I can authorize the G-Cloud SDK to perform all the cloud operations for the Google Cloud Platform on the behalf of moi. So I click accept, and I'm good to go. But not only that, I can type G-Cloud auth list and show all the different accounts that I have activated on with the SDK. So if you use 2 different Google accounts, say one for managing your prod environments or one for managing your dev and test environments, you can seamlessly switch between the 2, all with a couple of commands. OK, so enough about G-Cloud. Let's get back to fixing Fluttery Bird. Google has the Git repo in the cloud. How do I bring that to my local machine? I could go back to the web, find the right URL, git clone, set it all up myself, or I can just type G-Cloud init Fluttery Bird, where Fluttery Bird is the project name. This is going to automatically bring all the context and set up my Git repository. And so it's ready to go for me to make local changes. I'm going to change directories. So here's all the source code that I have. In fact, if I type git log, you can even see the commit that I made on stage a few minutes ago. And so from here, I can just use the tools that I'm used to. For example, the world's greatest operating system, I mean text editor, Emacs. And I can finally just get rid of that unit test. All right. And then I can use the standard, Git workflow that I'm used to. And so to fix Flutterybird once and for all, trigger the cloud build, cloud test, and deployment, I end it all with a git push. So while I'm super excited about the developer tools that we're building and showing today, as well as the ways in which it can make you more productive, the thing that excites me the most is that we're just getting started. And with that, I'll give it to Ray.
Okay, let's switch back to the slides, please. To bring it home, here are the features that you just saw. To give you an easy getting started experience, the SDK can be installed by a single command line. The component manager lets you see which components have been installed and add new ones as needed. You no longer have to worry about, do I have the latest version of SDK or not, because we have auto-updated notifications that will keep things up to date for you. I love gcloud, but I have to tell my favorite command there is gcloud init. You saw how easily it provisioned the entire workspace for any project you want to work on in just a matter of seconds. We want to make command line tool easy for you to use. We don't want you to have to memorize and spelling the other commands. So we provide you with auto-completion. You can just tab, and it's there. There's unified help in a tool that allows you to easily discover and learn new commands as you go. And we also make a big effort to try to keep command line, UI, and API consistent, so you only have to learn it once. In a single SDK, you get all the tools for Google Cloud. Some of you, I saw a show of hands, can see a show of hands, might have used GCU2 or app config in the past, right? Remember, you had to download them separately, keep them up to date, install them, learn them separately. Well, that was the past. Now they are coming to gcloud, so there's only one tool you need to care about. Now, in the last 45 minutes, you saw all the dev tools that we have built this far for Google Cloud Platform. You remember the browser-based code editor diffing tool, to log to source linking, push to deploy, and an all-in-one cloud SDK. These are just our first steps. We're going to continue to be relentless in our quest to give you the DevOps experience that you deserve. Thank you, and with that, we're happy to take any questions. So you also have my email there. If you want to reach out and ask questions offline, you can send your email. Chris, on stage? Yes, question there.
There's a critical missing step here, which is debugging. What are you going to do about debugging?
The question was, what are we going to do about debugging? I can't announce anything just yet, but that is a critical missing step, yes.
And I have a friend sitting on the same floor. That's about as far as I can say.
Test, 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 test.
Any other questions?
Yeah, that's exactly what we're working on. We understand that. Oh, sorry, the question is, you use multiple environments, right? Go from testing to staging to production. Do you do that from the same repo? How does that work end to end? And that is exactly the thing we're working on. We understand it's not just about single stage. There are multiple stages. And you know, sometimes you want to push code all the way through. Sometimes you want to push binaries all the way through. And that's what Chris and his engineers are working on. You want to say more?
Yeah. This is my day job, is solving that exact problem. Yep. All right. So fixing improving the environment management experience is exactly what my teams at Google are working on. And it's currently the push to deploy workflow is pretty straightforward. You have a single App Engine app and a single Git repo that whenever there's a push to the master branch, it gets deployed. But there are many other workflows. For example, maybe you want to have different App Engine versions triggered off different branches. Maybe you want to have different repos entirely with different ACLs between them. You have a prod repo that then goes through the deployment workflow, or a separate, different like staging or dev repo. So we understand that we need to be very flexible in our tooling. And over the next few weeks and months, we'll be rolling out the evolutionary steps of push to deploy to enable exactly this sorts of things.
Yeah, we have a microphone in the audience, so next question.
So how about the GitHub integration? It was announced this morning, but I don't think it's available yet. So using GitHub instead of the Google repo?
It's there. We'll be launching it, I think, publicly in a couple of weeks, or like rolling it out wider in a couple of weeks.
Okay.
So most of the demos that you just saw, if they're not already in production, they're currently in our Canary environment. They're like hot off the press. They're on their way, rolling out in the next few weeks.
You may have saw a link on Brad Abrams' talk about the Trusted Tester program at Google. That's how you can get a sneak peek at some of the features that we're working on.
In the Git repository, is there a way to sandbox, if you invite a developer to sandbox the access to the certain portions of the project, or do they automatically just get access to the entire project?
Git currently doesn't, our Git setup currently does not support that. The ACLs for the repo, as in who can access it, are tied to the project. So people who have edit access to that project can modify any part of the Git source repo.
And there's a question here.
Or there's the, let's follow the line.
Hey, I'm just really curious. You talked earlier that you have one source tree, but the tooling that you're generating now seems to deal with, if you have, say, one repo, it goes to one instance. So it seems like kind of different concepts. And I've always done it the more repo way, but are you working on, if you have a giant source tree, push out of this branch of it, or how do you relate those concepts?
So that's a really good question. It's talking about, within Google we have a single repo, as Melody talked about, but we understand that's, people do these things differently. There's some companies that like to have just a single repo. There's some companies that like to have, we've had customers with a few hundred repos on GitHub. And that's where we think flexibility is really important. We want to be able to support these different modes of working. And we also want to make sure that the benefits on both sides, we can give it to these both camps. For example, one benefit of having one repo is that it's easy to search across them, and it's also easy to reference different parts of things. And when a common library, when there's an issue in a common library, it's fixed for everybody. But we think these benefits can be true even if your preferred way of working is having multiple repos, and that's something we're working on.
So do you guys currently offer any way to speed up the tests themselves? Do you guys do any kind of parallelism in what you guys are offering, or is it basically just like hosted Jenkins?
Currently, we don't have any tooling about speeding up tests. It's just as quickly as you can configure the Jenkins master to execute them. But that is a problem that's on our radar. I think we have time for one or two more questions.
And I also want to add that sometimes it means allowing you to be, for example, be able to choose which size of VM to host your Jenkins, depends on how much your workload, and that's definitely something we're looking at. Yes, one more there. So the question is, do all the command line tools run Windows as well? And we actually have an expert here who can answer that question. Manfred, you want to comment? Yes.
Yes.
The answer is simple, yes.
All right. All right.
Okay.
Great.
All right. Thank you.
Thank you.
Bring 4 down. A little bit. No, not all the way.
It's on. It's on up here. Do you want to talk?
Yeah. Yeah. A little. Test. Test. A little bit lower. Test. Test. A little bit lower. Huh? I'm sorry.
It's on in the feed, and I can shut it off in the house.
Got you. Thank you. I'm sorry.
And you made me miss a cue by having this conversation with them, so talk to them about it.
Test. 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 Huh? I thought you said keep this baby noise going. This is only in the line.
Do you have any audio going out now?
Lalo.
One, two, three, 4, 5, 6, 7, 8, 9, 10. You hear me? Yeah? It's good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Okay.
Just saving it for the show.
Yeah, it's good? I think so. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good? All right. All right. Hello, everyone. Hey. Hello, everyone, and welcome to our session, Seeing Inside Your Service. My name is Amir Hermelin, and I'm a product manager for Google, and with me is Asaf Zemak, an engineering manager for Google. And we're here to talk about the exciting things we're doing and planning for monitoring and logging. Before I start, I'd like to thank you all for attending, for coming to our conference, showing your support, being loyal cloud users, Google Cloud users. So we really rely on your support and feedback. So thank you. Before we start, a show of hands. How many of you actively monitor your services? Please raise your hands. Okay, great, you're in the right place. Keep them up, keep them up. How many of you like it when you're firefighting and you're sifting through the information, trying to drill down and find the relevant information? Okay, that's good, that's good. And how many of you love it when you're woken up at 3 a.m. to do that? Okay, you too, you are our lucky winners. Now the rest of you, oh, where's my clicker? Here's what we're going to be talking about. So quick look at the agenda. We'll start with what we've learned over the years and our plans and vision for logging and monitoring. Then we'll talk a little about our new logs viewer. You may have seen it at this morning's keynote, and our logs ingestion pipeline. We'll then go over our new time series API, which is the first of many upcoming APIs in this area. And we'll conclude with a quick demo, kind of putting it all together. So, monitoring at Google. As you're probably aware, at Google we run many services, and we've been doing so over the years. Small services, large services, from really experimental alpha type services run by 2-3 person teams, all the way up to Google search and tens of thousands of queries per second services that are managed by distributed teams all over the globe. And internally, we've built very capable and sophisticated monitoring systems for keeping these services up. And over the years, we've learned many lessons. Some were harder to learn than others. But we think most of the things we've learned apply equally to large and small services, no matter what you're running. So some of the things that we've learned over the years. First of all, what you want to do with your service is you want to catch problems early, before these problems are visible to your users. Because when your service is down or when your users have a hard time accessing your service, that means downtime. You might lose revenue, you might lose mindshare, you might lose users, and it might be all over Twitter land. So you don't want to get to that point. You want to catch problems early. You want to be kind of extra careful. And so you go on, you add alerts, you add dashboards, you have logs, and all sorts of indicators to make you aware of problems before they occur. But that introduces another thing. That introduces noise. That introduces a lot of information, that really desensitizes you from the real issues that occur, the real things that you should focus on. And so what we've learned is that you should focus on and alert only on symptoms. So focus on how will things affect your users. Will these things affect your users? Is this a real problem? When will my users kind of start sensing it? And if you're firefighting, where should I start? I should start with the things that matter to my users, that are visible to my users. So that's what we've learned over the years. But of course, what we've learned and what we've done is not enough. We went out and asked you and other cloud users what they would like to get from their monitoring systems. And so here's what we're hearing from you. Lots of you are telling us that you've had alerts, but you had too many of them. They were noisy, and you ended up ignoring them, maybe partially, maybe in full. How many of you can relate to that? Okay, good. Well, it's not good, but yeah, I see some people in the audience who know what I'm talking about. Maybe a relevant thing, maybe you've heard or you remember in the past few months some credit card fraud occurrences that happened at large online retailers. Now, in most, probably in all these cases, from what I understand, the problem was not that they didn't have indicators. They actually had many logs. They had many alerts. They had many indicators. They might have had too many, that they've ignored some of them, that they had a hard time sifting through the rest of them. And by the time they found out about the problem, lots of credit card information was stolen. It became public, a huge problem. And these things sometimes take years to mend. So that's being too noisy. Now, too many of you have told us that our existing log viewer for App Engine is just not enough to find the relevant logs. You have many logs. You have a lot of logs volume, and you'd like something better to help you sift through them and get to the relevant information. How many of you, yeah, think that? Okay, good. Okay, you're in the right place then. I am too. So most of you are telling us that you need a better monitoring solution. You need better monitoring and alerts for things that are running in production. But you just don't have the time to spend on it. You want to ship new features, and you don't have the time to become experts at monitoring. And it's not just learning the system, but learning how to monitor. And then absolutely no one, except these two gentlemen over there, tell us that they love to be woken up at 3 a.m. Definitely if it's for the wrong reasons, right? Sometimes there are the right reasons, but if it's something that is not urgent or could have been handled automatically, nobody likes that. And unless you're a parent to a toddler, you don't really need to wake up at those times. So what you're telling us that our monitoring solution needs to be, it needs to be actionable. So everything results in an action. So alerts or dashboards or things that remove the noise and help you focus on the right things. It needs to be scalable. So even small teams can manage huge services. It needs to be easy to use. So a great out-of-the-box experience and easy to iterate upon until you get to the right setup, the right dashboards, alerts, and logs that you're surfacing. And it needs to be smart. So if it does wake you up at 3 a.m., you need to get out of bed and in your pajamas either grab your laptop or get to work and fix something. So where are we going with all this? So we took what we've learned and our existing systems and what you've been telling us, and here's what we want to do with our monitoring systems: dashboards, alerts, and logs. We want to surface only the relevant information, right? So you can understand better what's happening and how is it affecting your users. We want to minimize false positives so you can react faster and not ignore real issues before they occur or during firefighting. And we want to help you automatically detect issues and find relevant events and relevant information that helps you running your services in production so that even small teams can scale up and monitor and manage huge services. So we want to help you be insightful and react fast. And I want to remind you something that Bobby said this morning, the CTO of Snapchat. He mentioned that they have a relatively small team running a huge service, right? They have tens of millions of, or probably hundreds, millions of users and many queries per second. And he said that most of the time they spend is on rolling out and iterating on new features and very little time on managing the platform. And that's what we want to help you do. We want to help you scale monitoring so that we manage your monitoring for you, and you can focus on getting features out the door. Okay? And with that, I'll hand it over to Asaf.
Okay. Come on. Okay, so the first thing I want to introduce today is our new logs viewer and pipeline. So here we show the new schematic of the new logs pipeline that we're introducing today. This pipeline is today hooked up to App Engine, and we'll be hooking it up to our other services over the coming weeks. And what the nice thing about this pipeline is, it's a transport mechanism for logs going from one Google service to a number of Google endpoints. The first of these endpoints is the new logs viewer. I mean, you've seen it demoed today in Brad's keynote address. And additional endpoints that we're introducing today are Google Cloud Storage. So if, for example, you have your App Engine logs and you want to do some kind of batch processing on top of them, you want to run maybe Hadoop on top of them, so you can opt into this option of having your logs show up in Google Cloud Storage. And what we will do is we'll take these logs, we'll buffer them, and we'll produce hourly files inside Google Cloud Storage, and those are good for batch processing. Additional option for you is to opt into BigQuery. So for example, you can have your logs, your request logs as they're coming out of App Engine, flow through the logs in the new logs pipeline into BigQuery through the new streaming API that was announced today, and have those available for doing the SQL queries on top of them for kind of business intelligence applications. So that's the new logs pipeline. And the logs viewer is available today. The cloud storage and BigQuery options are available in Trusted Tester, and Amir will give information at the end of this presentation how to contact us and get to be part of that Trusted Tester. So this is the new logs viewer. This is just a screenshot. I will not be doing a demo of it since Brad has already gone over all the features. I do want to just go over some of the improvements we're introducing. So the first of these is infinite scroll. It makes it a lot easier for you to move around in a log, to find the log you're interested in, to scroll up, to scroll down. It works really well with the mouse wheel, for example, and there's no more of the page backwards, page forwards. We think it's going to be a lot more convenient. The second thing is this automatic searches. So this is probably the #1 feature request we've had from the old logs viewer. I don't know if anybody has ever run into this when you do a search and nothing comes out and you have to kind of page forward to find it. So raise your hand if you've ever kind of encountered this behavior. Yeah, I kind of thought so. So this problem is now fixed. The new logs viewer doesn't exhibit this behavior. So I think that'll make a lot of people happier. If we're already talking about searches, we've introduced an improvement in searches, so now you can do a search both on labels and regular expressions from the same search box. So that's a lot more convenient. And we have suggest as you type, so if you're trying to find, for example, something where the result code is 500 and also contains the word success, as you start typing result code, we'll help you kind of fill in that label. So it makes the logs viewer a lot easier to use. So switching over from talking over the logs viewer, I want to introduce one of our new APIs. So the first of the monitoring APIs that we're making available, and there'll be many more coming. So what is the monitoring API that we're introducing today? So we have a monitoring system built inside Google that what it does is it periodically samples important system counters. So right now it's connected to App Engine and Compute Engine, and we collect, as these systems are running, as they're running your applications, our monitoring system samples various counters, for example, how many requests you made, what the latency of the request was, how much CPU you're using, and we're collecting all those, we're passing those through a pipeline of monitoring data, and we're storing it in a storage in a monitoring store. And now, today we're introducing an API which allows you to access that monitoring information and get metrics, a time series of data. So for example, the history of all the result codes you have in your App Engine application, or the history of your CPU utilization in GC over time. And what you might do with that is, so one places where this time series information is used is, you've seen all the nice graphs in the Cloud Console. Well, those are based off of that time series information, and that's like one common usage for that. So this is the list of the metrics we're making available today. You see we have a list of App Engine metrics, we have a list of Compute Engine metrics, and we can go into them in more detail, and we'll be introducing much more later. So what does a request look like? I'll go into this in some detail. So it's a standard REST request. The first part of it is the URL. Google API's Cloud Monitoring is where this URL, where this API lives. Then comes the version number. So this is version v2 beta 1. So it's still a fairly early version of this API. Then you tell us which project you're interested in. Then you tell us what you want to get. In this case, you're trying to get a time series. Then you're telling us which service you want to get the time series for. In this case, it's compute. There's an analogous service for App Engine. And similarly, there's no instance information. You're telling us which metric you want to get. In this case, you're telling us you want the usage time. And the response you get for this is essentially it's a JSON object, tells you what information you're getting. There's some metadata. So, for example, it tells you what your project information, the metric name, some label information, then followed by a series of points, essentially a start and end time and a value. And so it's a very classic time series information, very simple to use. And with that, I will want to go to a demo. So what are we going to see? So earlier in the presentation that Brad did here, he showed the Cloud Meme backend. So we had an application where someone was running, was using an Android application to talk to something running on the front end in the App Engine, and that was talking to a back end running in Compute Engine, and that there was a MongoDB element in there. So all these things were running, and as they were running, we were in the background collecting metrics for them and putting them in the Google Cloud Metrics Store. And now we'll see how we can access that. So can we switch to the demo? Oh, excellent. OK, so first, I will go to my directory to see I'm in the right place. And now I'm going to log in using OAuth. So the monitoring data that we have is protected. It's only your monitoring data. So it's not available through using standard curl commands. They have to be OAuth-enabled curl commands. So we can protect. So your monitoring data can only be accessed by you and not by anybody else. So here we use the OAuth curl command that's available off of code.google.com. I log in. He asks me to allow access to it. I allow the access. And now it gives me an OAuth token. The OAuth token is stored on my machine. It's good for about an hour. And now I can issue OAuth curl commands to get my monitoring data. So this is the Java OAuth curl command. As you can see, it's a fetch command. So we're doing the OAuth fetch. And we're getting the Google APIs, as I showed earlier. MemeDroid backend is the name of the project on the computer. In Google Cloud console, and then we get the exact instance. And there it is. It's all working. You can see it tells us what we got, the kind of information, some metadata, and again, points all the way down, just time series information exactly as you would expect. And now just to show you that there's something useful here, we have a little plot program. It wouldn't be a demo if it didn't work.
Live demo.
Yeah. All right. All right. Should we skip that? Should we skip the visualization part?
Yeah, it's a nice graph that shows you what's going on, but this is the API that we're showing you.
Yes. OK, so we'll go back to the slides. OK. So
is it not working?
Yeah, we're not clicking to the next slide. Why is the clicker not clicking? Oh. So we did this. Yes.
OK.
Hello? We're having some issues.
Well, you can only go back in time, I see.
Yeah. Why are we not? OK. OK. Where are we? Excuse me. Can you send us back to the slides where we need to be in the demo?
Yeah. So we're having some issues with the slides here. Can you hear me? Is my mic working? OK. Do you guys have a mic for me?
Can you send us back to the slides?
I'll take one of these. Oh, OK. OK, so never mind the slides. This wouldn't be a live demo if something wouldn't happen. So thank you, Asaf. Let's give a hand for Asaf. His team. Thank you. East team has been working hard to get you these features and the upcoming features. Some of the things that we're working on is extending the APIs, bringing you dashboards and alerts, and working on other logs functionality to make the monitoring and logging experience much better, easily managed, and kind of take your time off of that, and so you can focus on shipping features. So a little bit about, again, what we've covered today, right? We spoke about our vision, the things that we've learned. We want to bring our systems, our power, our scale, our monitoring systems to you, but in a simple and intuitive way, so you can get started quickly. We showed you our new logs viewer and our logs ingestion pipeline, which is, by the way, in Trusted Tester, and I'll tell you how you can take part in that in a little bit. And we went through our time series API, which is, again, is the first of upcoming APIs to give you programmatic access to your data to help you build on top of what we're offering. So you can extend what we're offering and do other things that we might not have available today. And we took you through a demo, and I'll remind you that what didn't work is plot, which is not our stuff, but the rest of it is, I assure you, is working well, and it is in Trusted Tester, our monitoring API. So we thank you, and one important thing is we really, really appreciate your comments, suggestions, and feedback. If you have something you want to tell us, or if you want to be part of our Trusted Tester, these are kind of several Trusted Tester programs. The email is here. I don't know if you can see it. It's monitoring and logs feedback at google.com with dashes. So monitoring and logs feedback at google.com with dashes. And also, we'll be here after we're done to answer any questions. Do we have time for a little Q&A? Yeah, okay. So any questions? And please speak up.
No, we have a microphone.
Oh, okay, we have a mic. Awesome.
Was one of the items that you were able to monitor the rights to the data store?
Sorry?
Were you able to monitor the rights to the data store?
Yes. So we have, along the list of metrics that we showed available, there is rights from GCE, rights to disk, and there's rights to networking. So there's both networking and disk access metrics for GCE, for the compute engine. For the app engine, no, I think it's mostly around so we have resource, we have, can you bring up the list of slides? Can we go back to the list? Let's just, instead of me trying to remember it by heart, we can just bring it up. We can just bring it up.
By the way, we're adding to this list.
So we have responses, we have quota denials, usage, page speed received, and sent bytes over the network. So that's what we have available today. So that's the list of stuff we have available now. And part of the reason why we're doing Trusted Tester is exactly to get feedback to say, well, it really would be useful for me to get data store bytes, so we can add that stuff.
Any other questions? Yes.
So you showed the metrics from App Engine and Compute Engine going into your metric store. Will you be able to send external metrics to the metric store from an external source?
So by external source, do you mean your own apps, or do you mean
outside of Google?
Yes. So we will have an metric ingestion API for your user-defined metrics. That is futures. I don't want to talk about it too much, but it will integrate with the rest of the system to be kind of a first-class citizen. So all the wonderful things that we're working on for our metrics will also be available for your metrics. Yes? So the question was, do we have any similar plans around Google Cloud Storage? And the answer is yes. And there was a thumbs up. Next question. Okay, I think we're also kind of running out of time. And one last question. Okay.
Sorry, can you show again the email address, because I was trying.
Yes, of course. Monitoring and logs feedback at google.com with dashes. Or amirh@google.com if you can't remember that. What's that?
He gets an error when he sends an email to that.
Oh, okay. Give us. Oh, it works? Okay. Enough things not working for this session, right? All right. Thank you, everybody. And please let us know what you think. We'd love to hear your feedback. Thank you. Thank you.
כמה שאתה בודק, אתה בא לפה, מחליפים לך את הנטוורק וכל מתחבר.
Let's go. Cool. Okay. This is a really good crowd for a 2:30 session. I'm impressed. So hi, everyone. I'm Andrew. This is Johan. And we work on Google App Engine. And Johan and I, and in fact the App Engine team, are really excited about today's launch of Managed VMs, which combine the turnkey simplicity and ease of use of Google App Engine with the raw power and flexibility of Google Compute Engine. Now, you might have seen a few demos today where we showed you how Managed VMs allow a developer to build really complex, rich applications using the existing runtimes of Google App Engine. That's Python, Java, PHP, and Go. And what we want to do today is both dive into that in a little bit more detail, but also answer the question, what if we were able to bring our own runtimes to Google App Engine? What if we could customize the language and the serving stack that we want to use? So, but just before we get into that, I just want to recap Google App Engine really quickly in case you're not familiar with it. So Google App Engine is our platform as a service product. It's been phenomenally successful for us. Every day we get tens of billions of hits across our service. And when we look back and we ask our customers why do they like it, what's the reason for its success, time and time again what we hear is simplicity. Simplicity is things like turnkey application deployment. It's things like automatic provisioning and health checking and logging and monitoring. It's things like deep integration into our core services like data store and cloud storage. And last, but by no means least, it's having a complete local development environment ready for you so you can code no matter where you happen to be. So what Managed VMs bring to this picture is the same power, the same simplicity, but with far more flexibility than you've ever had before. Managed VMs really take App Engine to another level in terms of flexibility. We're going to demonstrate a little bit of that today. What we're going to do in this talk is build an application that uses Managed VMs extensively. It's going to have two large components to it. One of those components is going to be a Go application. We're going to run that Go application inside Managed VMs. Because it's running in a Managed VM, we're going to do things on that Go application we couldn't do before, like callouts to a separate process that's been installed separately, written in C. And then we're going to go a step further, and we're going to show how we can take some of those same abilities and run them in an entirely new runtime, one that we've customized ourselves. In this case, we're going to use Node.js. We're going to show Node.js running on App Engine. And then finally, for a kicker, we're going to show how in gaining all of this flexibility, you haven't lost any of the benefits of App Engine. You still get local emulation. You still get great integration. You still get the same rich App Engine experience. And in fact, you have the same experience for your Go app and for your Node.js app. Both of those components run within the same application and have access to the same shared data using App Engine modules. So let's start at the end and talk about the application that we're going to build here. We wanted to build something that was inspiring and something that was innovative and energetic, something really googly. But we also wanted to build something fun. And at the end of the day, we realized that building something fun was a lot better than building something that was inspiring or, God forbid, practical. So what we've come up here, I really like this demo. It's called Cacophon. It's a collaborative cacophony machine. And we're not going to show you the URL just yet because we don't want to get trolled. But Johan's going to give us a quick demo now.
Okay. So it's a very simple app that has like a few knobs on it. It all started with some work from Andrew Guerrand from the senior office with an engineer who worked on Go. And he did like this synthesizer engine written in Go. And we decided to write HTML5 frontend for it. So here you have the knobs. I can turn them. It will generate a new sound depending on the parameter. It can get pretty noisy. So I'm going to stop here. What is interesting, though, is that if I hit the share button, it's broadcasting this sound to all people who are connected to this page now. And like, we have someone in the room who is trying to connect to this page right now, is sharing sound with us. So we can somehow play together and look at who is like generating the sound that is the weirdest. So I think it serves its purpose well. It's really a cacophony generator. So if we could go back to the slide.
I swear there's a knob on there. They don't call it this, but it's the chalkboard scratching knob. So let's take a quick look at what it takes to actually build a collaborative application like this. And there's really three moving parts when you think about it. The first part is the HTML and JavaScript that's actually running in the web browser. This is what's giving us that nice HTML5 UI that you saw, and it's also what ultimately plays the sound through some speakers. And because this is a collaborative application, we actually have multiple copies of these things running. Every time someone visits the app, then they're going to end up with a copy of this part of the application running inside their browser. Behind that, then, we have the web server. This is where Node.js comes into the picture. And the web server is really responsible for doing two things. It needs to serve HTML5 and JavaScript so it can get into somebody's browser. And then we also need to provide a way for connecting all of those browser clients back to each other so that when one person shares a sound, that sound is then distributed across everybody. So to do that, we're going to use WebSockets, and we're going to rely on our web server component to be able to connect all of those clients together and act as the broker. And then behind that, we have what's really the meat of the application. This is the audio generation component. This is the part of the application that is able to take as parameters all of the knobs, chalkboard scratching or no, and from that, first create a waveform, and then from that, create an MP3 file. And then we pass that back to the browser. So for this, we're going to rely on some open source code that our team in Sydney came up with that allows for waveform generation and MP3 generation. And so Johan, why don't we cut to Johan and you can take us through
You want to talk about the protocol?
How that works. Oh,
yep.
Let me give you a quick summary of how this component actually works. So we're going to, because we want to talk between our Node app and our Go app, we want to have some kind of easy mechanism for the two to communicate. So this Go app's going to use, it's going to use HTTP. So we're going to send a HTTP request. It's a GET request, and that contains the values of all of the knobs that were on screen. It's going to create the waveform, and then in the HTTP response, we're going to get as a payload the MP3 file that contains the audio we want to play back.
Okay, so if we go back to the demo.
Cut to Johan?
Yep. So here I am in my terminal, and I'm in the demo directory. As Andrew mentioned, there is multiple components to our app. There is a front end and the back end, and we're going to take a look at the back end first. So we're going to open backend.go. That's where the meat of our application is. It's like a regular Go HTTP application. You can see the handler in there. We have an handler for /audio that Andrew mentioned. And the interesting part, the thing that we couldn't do on App Engine before and we can do now with ManageVM is that we could use the exec package that is from the Go standard library and execute a native binary. And here we are going to execute lame, which is an MP3 encoder. We're going to stream the waveform in and get the MP3 back from its standard output and just stream it back to the HTTP response. So in order to deploy that to App Engine, I'm just creating an app.yml file. It's really looking like your regular app.yml file. There is runtime Go in there. One thing that is different is that I have a flag that is called vmtrue. Another thing that I have is that I have this apt-get install stanza that says that I want to install lame. So let's take a look at how we can run this application on our laptop. So I'm back to the command line. I'm going to run gcloud app run backend. So first it will build my application. Then it will build my application container. Because it's not my regular App Engine app here. I have more than only my Go binary. I also have this third-party executable that I want to install. So for that, I need to package my application as a container. And then it will run my container locally on my laptop. So now I could go to my browser and open localhost. And here I have a series of links that I could open. That is a few presets that I set up before the demo to generate some example sound. The first one is the default one that you heard before. Can I get some audio? Yeah. It was just a regular sound. Another one more aerial. And the generator is pretty flexible. I could also have pure noise. So we're going to back to Andrew and stop the noise.
Cool. Back to the slides, guys. Okay, so now this is cool. Now we can make some noise. So now what we want to do is take this and make it collaborative. So we want to add a rich front end, and we want to add bidirectional communication to this. And as we mentioned, we're going to use Node in order to do this. And fortunately, although you might think that rendering a lot of HTML, creating a web server, handling a lot of back-end WebSocket connections might be complicated, the good news is there's a ton of great frameworks that actually help us do this. One that Johan and I happen to be big fans of is called Sails.js. But Sails.js relies on Node.js. So the question now is, how do we get Node.js, which is a popular JavaScript server, how do we get that into App Engine? So to talk about that, let's have a think about what happened when Johan ran the Go application before. So in the Go application, he told App Engine that this was going to be a Go application by specifying Go in the runtime flag of app.yaml. And what that tells App Engine is basically 3 steps that need to happen. First, it tells App Engine to define an environment. Now here, when we say define an environment, we mean bringing in any dependencies, any executables, any code, anything that's necessary to run your application outside of the application itself. In the case of the Go application that we saw before, really this is pretty simple. This is just bringing in that lame executable that we saw earlier that's creating the MP3 file. For something like, say, a Java application, we might do something more ambitious here. We might need to bring in a servlet container like Jetty, for example. The second step then is building the code. Now, this is things like compiling, things like asset packaging, things like bringing in packages that might be dependent on your code. It's the sort of step that still requires some build and install, but this is the sort of thing that you want to happen whenever you might want to kick off every time you make a change to your code. So in the case of our build step for our Go application, we were taking our Go code and we were actually compiling it. And then finally, we have the run step. What the run step is doing is saying that now we have all of our resources and assets running in our compute container. Go and execute something. Go and make it happen. So what we're doing with App Engine is introducing a new value of runtime, which is simply runtime custom. And what runtime custom does is it removes any assumptions that App Engine makes about the language or the development environment that you happen to be implementing inside App Engine, and instead replaces it with 3 shell scripts that you define yourself. So these are just straight up Unix shell scripts. And these 3 scripts correspond to the 3 phases that we saw before. So there's one for bootstrapping, one for building, and one for running. And so once you have this, it's easy to start thinking about how you might use this to set up a Node application. So now, Johan is going to show us how this works.
Okay, so I'm back into my Gmod directory. So Andrew mentioned that we have one more component, which is the front end. And I'm going to show you that in one moment. So our application has 2 components, the back end, the front end, and we need to somehow dispatch the request between the 2. So for that, we have a dispatch.yml file, which is just something that maps URL to module. So here we say everything that is audio goes to a back end, and everything else goes to a front end. So I'm going to open the front end now. I'm going to show you that it's just a regular Node.js application. I have a package.json that defines my dependency. I have a servers.js that jumps right into Sails, which is the framework we are using. And then I have my app.yml file, which is what Andrew just mentioned. Here you can see that I don't have Node.js for my runtime, I don't have Go, I don't have Java, I have runtime custom. And I still have VM true. And I have those 3 scripts sitting in my app directory. The first one is Bootstrap. Bootstrap is really for bootstrapping my runtime environment. That's something that I will share for all my Node.js app. And it's here what we are doing is we are just mainly doing a few apt-get install and getting the Node.js binary distribution from nodejs.org website. And we are also installing Bower, which is a tool that we will use to package our front-end dependency. What is interesting to see here is that even if we change our application, we are not going to rebuild this from scratch. It will be cached by the system. Then there is my build step, which is really about bootstrapping, really about building my Node.js application. So in case of Node.js, where you don't really have a compiled step, building is more about installing your application-specific dependency. Here I will run npm install to install the dependency I configure in my package.json, and just bower install to install my front-end dependency. Again, this will only get run each time that I change my application. And the last step is run.js. which is just running my Node.js app. In that case, I just call Node. So that's a pretty flexible way to describe how you build your application. But today, in the open source world, there are also new ways that people are adopting in order to build application container. And we've looked at this with we are very interested by what is happening right now, and we decide to add it as an experimental feature support for Dockerfile inside the App Engine SDK. So here, you basically have the same contents that you had before in your Thresh script, but used in a Dockerfile. So the difference is that it gives me more flexibility on each of the operations that I want to do, because each of one is like in the same file. And also I could leverage caching better, meaning that, for example, I don't have to reinstall my dependency if I'm changing my app, because I could add the package.json to my container image before adding the rest of my application. There is also a few additional metadata that I could define, because I'm in a container. I could define the port I'm listening to, and I can define the command I will use to run my application. So let's see now how to run this application. So not only the Node.js, not only the Go backend, but also the Node.js frontend on my laptop. So for that, I'm going to call gcloud app run. I'm going to pass 3 modules that I want to run, my dispatch module that I've shown you earlier, my frontend, and my backend. So now first is starting to build my Node.js frontend container images, so using the Dockerfile or the Bootstrap script that we defined before. It's now building my backend, building the container for my backend, and soon the application must be serving for my laptop. So here I know that the dispatcher, which is the thing that will route request according to the path to either the Node.js frontend or the Go backend, is running on port 8080. So I'm going to go back here and open port 8080. And here I have the same app that I have in production running on my laptop. And I can continue to make sound that annoy you. So now what we want to do... Not that knob! So now what we are going to do is we're going to take this application that is running on... Let me restart Chrome first. We're going to take this application that is running on our laptop and deploying to production. So instead of doing gcloud app run, we are going to do gcloud app update. And now it's building our container and deploying to production. So we have like a few moments before Andrew takes back. So you can all go to cacophone-demo.appspot.com and start making noise. We can put back to the slide.
So jump on that, guys. That's live. cacophone-demo.appspot.com. And this is pretty cool. This is Node.js running an app engine. This is Go running an app engine together. So we're pretty excited by this. There's a few things that we've shown you here. One of the things that we perhaps didn't elaborate on before was worry-free coding. So first of all, we make available several services to every App Engine app by default. Every App Engine app gets a default cloud data store data set. And it can get access to that through the Cloud Data Store API. It's a great API. It's RESTful, OAuth 2, and we have clients in a number of different languages. And of course, you can roll your own. Likewise, we also provide access to Google Cloud Storage, also through a RESTful OAuth 2-based API. And every app gets a default cloud storage bucket. And then we also have App Engine's shared Memcache service. So this is actually free, and it's available through the Memcached protocol. And this is pretty cool. If you speak to a particular IP address and port, we will automatically segment your application, segment your Memcache to your application, and so you get access to your shared Memcache automatically. And that's shared between instances, and in fact, even between modules. And then finally, we take care of something that is always a hassle with distributed systems, which is logging and log aggregation. If you just write in a variant of the syslog format to a particular directory, then all the managed VM infrastructure will capture those logs, it will tail them, and it will ingest them into the Google Cloud Platform and make them available to you. And finally, one thing we should harp on is seamless local development. Everything that you saw there that Johan was doing was in his local environment. And that involved not only emulating the App Engine infrastructure, request serving and packaging, but it also involved emulating some of the services of the cloud platform itself. We emulated data store for you. We emulated cloud storage for you. We emulated memcache and logging for you, even for runtimes that we don't know about. And then, of course, to get that up into the cloud, it's really simple. gcloud app update, and you're done. So now that we've got this app live, now's a good time to talk quickly about events. Because this is a managed environment, App Engine will be, and the managed VM infrastructure will be provisioning your application possibly onto one VM or one instance, possibly onto many, and it might even spin up new instances and turn old ones down and balance traffic across them. Because of this, we might be ramping up and ramping down your application from time to time, and it's useful to be able to signal events to you that this is happening. We also mentioned health checking before. This is really important. As your application is running, the managed VM infrastructure, needs to know that your instance is healthy, that your serving stack is healthy, and that your app is healthy. So we will check periodically to do that. So the way we signal all of these events is using HTTP. We make a HTTP request to a particular URL on a particular port on your instance, and we leave it up to you to figure out how to respond to that. For our managed runtimes, that's Python, Java, PHP, and Go. We built all this in for you, although you can overwrite it. For custom runtimes, it's necessary to implement some of this stuff yourself. So one event is the start event. We basically call this right after we usually call this right after your run.sh script is run. And this basically signals to your app that it's ready to receive traffic. It's actually optional whether or not you want to respond to this or not, but it can be a useful signal. The next one, health checking, is really important. We will health check your app. We will call this at regular intervals. And what we expect back from our HTTP request is a 200 OK HTTP response within a reasonable time frame. If the managed VM infrastructure doesn't get this, then after a while, it's going to assume that your application has entered some kind of pathological state and it's not healthy. And so what we might do there is we might restart it or even possibly completely rebuild it and migrate traffic from a backup instance or to a backup instance. And then there's the stop event. This is kind of a best effort on part of the managed VM infrastructure. But what we're trying to do there, if we can do a graceful shutdown, is give your application a signal that it should be thinking about wrapping up and terminating any loose ends and any loose processes. So we try and give you a signal there that that can happen too. So we're really excited about where all this is going. This really is the beginning for us in the managed VM story and the managed runtime story. We're actually really excited about this, not only to see what runtimes that you're able to bring to App Engine, but also for what other teams inside Google can build on top of this infrastructure. You've already seen Go running inside App Engine today. That's a language developed entirely internally at Google. We're working now with the Dart.js team to bring Dart to App Engine as well, so expect to see that in a few months' time. And we would love to see more innovation happening on our platform over the coming months. So again, we're really excited to be able to talk about this. We'd love to see what you're going to come up with, and we'd love to hear feedback and hear where this is going. So thank you for your time. I know we're running it. So I know we're running a little late, and I know you guys are all getting hungry. So we might just take one or two questions, and then for any follow-up, feel free to talk to Johan or myself. Yep. Oh, great. There's a microphone right there.
Great demo. Is the dedicated memcache available, or sorry, is the memcache API available within the managed VMs, or is it only available from App Engine instances?
It's available within the VMs. So you can talk to memcache DY protocol to a particular port, an IP address, and you end up, what that ends up doing is bridging back to the shared and dedicated memcache service of App Engine. And then whether it's shared or dedicated, that's really just a configuration option on your app. And like with regular instances, you can swap over at any time.
The local SDK, is that running a VM, so it's actually, I mean,
yeah, behind the scenes, it's running an actual VM in a VM player.
It runs on Windows, Mac, and Linux right now, or?
Yeah, it does.
Thank you.
Definitely excited to see the Dart VM being pushed. I'm excited about that personally. So a question about local development. So if I want to use the managed VM system, is this going to work on Mac OS X? Because in the past I've seen some weird oddities where it really works well on Linux and it doesn't work on Mac. And the other question is related to it. Do I need to manage my own Docker file to run it in a container when I'm doing local development? And this is all related to local development. Like I can get that same exact experience locally developing versus once I push it or upload it.
Got it. So to your first point, Mac versus Windows versus Linux. An artifact of wanting to be able to properly emulate a managed VM means that we actually want to move the development environment to a virtual machine as well. And that has the nice side effect of introducing a lot of consistency between it moves a lot of the logic up to the VM, which we can then easily keep consistent across platforms. So hopefully that will help address a lot of the environment-specific issues that you see. And to the second question, actually the Docker file support is very experimental right now, so we're trying to see if we can get that into the product at the moment. Whether or not you'll be able to, whether or not you'll need to use the SDK to build packages and push them up locally, we're also still working on. Actually, right now you can basically push all of this up to App Engine just as a set of scripts, and we'll host the building for you. That may change in the future. We're still working on that.
But you still have those 3 files that you could define yourself, which is like a bit more simple, but you also have less flexibility than the Docker file, where you can just like say how you bootstrap your environment for Node.js, how you build your application for Node.js, and how you run it.
Yeah, we want to support both models. Either give us your source and we'll build it, or give us something and we'll run it.
So for the managed VMs, at least for if the VM is an App Engine one, my understanding is it's going to get rebooted once a week, I guess, to apply patches. So is that still the case? Is that handled through the stop event, and if you have 10 servers running, it's going to hit them with a stop on a rolling window so you can still have uptime?
That's right. So we will definitely be rebooting your machine from time to time. How frequently it happens will vary, but we want to make sure that the VM gives you a lot of flexibility, but it's not really a place for state as such. So it's not anything beyond, say, temporary files or anything like that. It's probably not a good spot for. And then yes, we'll send a warning signal where we can to give you some options if you need to migrate state to do that.
Okay.
Cool. We'll let you guys get some food, but thank you very much.
Forgot to show the local development server, the UI, the local console.
All good, man. All good.
Yeah, I forgot to show this. Forgot a few things, but that's okay. Sure, sure. Take care.
exactly.
4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5.
Does he have what he needs? Yes. I need the voice.
Gotcha. Does killing the mic help?
Yes.
Okay, so if I kill like that's off the problem. Yeah. So there's another guy who's doing the demo as well. You want to check his levels too? Alright, so it's almost time. Let's get started. If you guys have had lunch, good for you. Now time to join. Come. My name is Manfred. I'm here today with Rajiv, and we're going to talk about building cloud-powered Android applications. So this is going to be a very much a hands-on demo. We're actually going to take an application, write the backend for it like now, live in 15 minutes. And we're also going to give you a bit of introduction before we do that, and then we're going to talk about some of the future directions, and we'll try to leave a minute or two for questions and answers. So let's start with an overview. For this demo, we're going to be using Android Studio and Google Cloud Endpoints. And let me just give a quick overview of each of these. So Android Studio is an open source IDE. It's built for Android, and it's based on IntelliJ IDEA. Now, what that means is that it has a lot of good coding assistance tools to help you write quality Java code. So things like context-aware code completion and chained method auto-completion, optimizing imports, built-in spell checker, all of that kind of nice stuff. It also has a nice integrated visual and layout designer, which means that you can drag and drop visual elements into your app. And it also comes with a whole bunch of static code analysis tools. We call them linters. I think that's how they're known in the industry as well. And they help you to build quality apps, so they can check things like simple security issues and compatibility issues, all of that kind of things. And finally, Android Studio is very well integrated with Gradle build, which means that you can use the same build files and build setup for IDE, command line, your continuous integration server, all of these things. So that's one half. Now, the other half is Google Cloud Endpoints. And what Google Cloud Endpoints do is they provide a very simple way to build server-side logic for your apps on Google App Engine platform. And since it's running on App Engine, it's benefiting from all of these things that we just spoke about throughout the day. So auto-scaling, high availability, all of those nicenesses. So this is how a basic architecture looks like. You have a backend running on App Engine instances, and then you have Google Cloud Endpoints clients. And one thing that Endpoints does for you is they take the plumbing out of API programming by, for example, marshalling Java objects into JSON objects, providing REST APIs from your annotated Java code. Another thing that Google Cloud Endpoints does for you is they take the complexity out of multi-client development. So I understand that while you might be targeting Android as a primary kind of distribution source, there's also iOS and there's JavaScript. And so you can automatically generate strongly typed client libraries for those platforms. And then finally, endpoints also take the risk out of API development in the sense that there is out-of-the-box built-in denial of service protection. There is support for OAuth 2.0, and there's also support for things like client key management and so on. So anyway, when you combine these two things, you get something that's even better. And so in Android Studio, in my mind, Android Studio plus Cloud Endpoints is the easiest way for mobile developers to get to Google Cloud Platform. And we have a whole bunch of functionality in Android Studio which help you do just that. So you can create App Engine backends. You can generate strongly typed client libraries. There are also a bunch of quick fixes and as-you-type validations for when you're developing the actual API. And we're going to show you all of this during the demo in the next 15 minutes or so. And one thing I would just like to mention as well is that it's all using Gradle as a build system. So it's very well tied together and unified build across the command line, across IDE, for both the backend and the frontend. So let's jump into the demo. And we were thinking, like, you've seen a lot of cool demos today. We were thinking, what is something cool that we could show to you guys? And first we wanted to show like our own application, just write something from scratch. But then we thought, is that necessary? And we found this. We found the To-Do.txt app, which is a simple to-do task management app. It's on Play Store. It's loved by Play Store users. And it's using a different cloud provider for the backend. So let me just show you the app. If we can just cut to the mobile device. Ah, yes. Demo snag number 1. Let's see if we can cut to a different mobile device. Okay, bear with me. We're gonna get there. Let's try the mobile device one more time. Yeah, I was on it. Not getting it. There we go. All right, so it's a different device. Bring 2 devices to a demo if you're doing a demo. That's just like heads up. So this is the To-Do.txt app. As you can see, it does all of the things that you would expect from a to-do app. You can add a task. You can mark a task as done. Nothing groundbreaking, but it's a nice little app. Now, if we can cut back to the slides for one more second. Best of all, the app is open sourced. So we thought, let's take the app, let's remove the different cloud provider backend, and let's add our own cloud backend to it. So let's cut back to the device. This is exactly what we've done. So again, this is a To-Do.txt app, but now instead of using a different cloud provider, it's using Google Cloud Platform. And so again, as you would expect, I can add a task. Sorry, I'm going to try to add a task during the demo, which hero demo. Sure, why not? Good enough. Yeah, so it works as expected. And let's get back to the slide, please. And in fact, it was so simple and so easy to do this transition from taking an existing app and adding a Google Cloud Platform backend to it that we're going to show you right now live. Again, submitting to demo gods how to do all of this kind of stuff. So we're going to start with an app which is completely stripped out of any kind of backend, just the UI, and then Rajiv is going to do all the magic, and he's going to add a backend to it. So over to you.
Cool. Can you hear me? Is the mic? Okay, thank you. Cool. Thanks, Manfred. All right, so yeah, no pressure. Let's write a backend. All right, so here's just the architecture of what we're doing, because there's a lot of steps here. On the left side, you see the to-do text app, which Manfred showed, and as we dropped out the existing cloud provider. Right? On the right-hand side, you see the App Engine backend that we want to build here. It's going to use the cloud data store to store and retrieve tasks, and what we're going to do is then expose this backend using cloud endpoints. And once we've exposed the backend using cloud endpoints, we can generate strongly typed client libraries and then use them over in the to-do text app, and then we can communicate with the backend to store and retrieve tasks. So, okay, cool. All right, let's get started here. All right, so we're starting with the to-do text app. So what does that look like? All right, let me just go to Android Studio here. All right, I think you guys can see it. Okay, so what I have on the left-hand side, you don't have to go through, you don't have to read all the lines here, but it's the to-do text project here, and there's a bunch of modules here. To-do text touch, there's like an action bar widget and whatnot, and what I'm showing here is the main build.gradle file actually for the to-do text touch module. So, you know, I'm not going to go through everything here, but as Manfred was saying, this is using the Gradle build system, and this is written in Groovy. So this is what the syntax is that you're seeing. And right here, I've actually got, you know, one thing I'll point out is if you look at the compilation dependencies, there's a bunch of jars here, but then there's a couple of project dependencies, which are actually just pointing to the other modules there. So this is kind of a key point about using Android Studio. All of your Android applications use the Gradle build system and give you a much more rational way to build your app and do command line builds. So cool. Okay, great. Let's go back here just to see where we're at now. And all right, so what I want to do now is I want to generate an App Engine backend that has a cloud endpoint service. So let's go and do that. So I'm going to go up here to Tools. I'm going to go to Google Cloud Tools. I'm going to say New App Engine module. The template I'm going to use is the App Engine Java Endpoints module. Let's call this To-Do Text Backend. And the package name can be com Google To-Do Text Backend. All right, that looks good. So I'm going to generate. All right, so a couple things going on here. One, we basically have a series of templates, and you're seeing that over here, from the template code, we basically generated all this code here. And I'm going to go through that in a second. What's also going on is you're seeing that it says Gradle sync in progress. Because this is using the Gradle build system, anytime you add a module to your project, it has to be built and absorbed into the actual IDE via Gradle. So that's why asynchronized was going on here. So if we're looking at the build Gradle file here for the Android application or the App Engine application, you can see that this is using the App Engine plugin. This is a Gradle plugin for App Engine. The dependencies are on the App Engine SDK. You've got some compile time dependencies here. That's the main Gradle file. So let's hop into the code that was actually generated, right? MyBean is, well, it's, I guess, MyBean. It's a pretty simple class with like a single field. It's just got a string field, as simple as you can get for a data object. Again, this is part of the template that we generate. And we've got myEndpoint here. Okay, so myEndpoint's a little more interesting, because what this is it's actually it's a Java class, but we're exposing it as a cloud endpoint. How are we doing that? We're using the add API annotation, which you see up here, and I'm specifying a name of myAPI, which allows us to be exposed as a cloud endpoint with the API name myAPI. But you know, that's not much fun. You need a method, right? I mean, you have to call something. You know, you need some sort of RPC call. So there's the sayHi method that's also been defined here. And we've exposed this with the API method annotation and we've given the name here sayHi as well. And this is a really simple method. It takes a parameter, creates MyBean, and returns it. So let's look at what this looks like, actually. Let's see what this actually does. So I'm going to run this. Hit play. OK. So whenever we actually run, an Android or an App Engine app in Android Studio, because it's using Gradle, it does a Gradle build beforehand. And then what it does is it kicks off the local development app server. You saw this in a previous demo. actually, and it's starting. It just kicked me over there. So it just started. But basically, this allows us to test locally before deploying to production. So let's take a look at what our sample app looks like here. So what I'm doing here is I'm basically opening up API Explorer. It's an app that's basically pointing to my local host here to slurp in the API meta information to provide me a view over the REST API. So you see that an API called MyAPI has been defined. There's the say hi method. And it takes a parameter. It's a name. So I'm going to just put in Manfred. It's not my name. It's his name. But hit execute. And there we go. So what actually happened here, right? You see that the Java class I created with the annotations has mapped pretty well into a REST API. If you look at the post, just zoom in here a little bit, you've got MyAPI in the name, version 1, that's the method, that's the data. The response is hi Manfred. So that's basically the API Explorer. That's just showing you how we're exposing a cloud endpoint really simply. So okay, let's go back over to Studio here. All right, let's stop the dev app server. And okay, let's checkpoint where we are here, right? So what we want to do is we've got the backend, we've got a cloud endpoint, that's great, but that's not really helpful for what we're trying to do here. We're trying to store tasks in a data store and get them back. So let's work on that part of the app. So go back to Studio, and what I'm going to do is, so I'll start with this sample. It's good. I can get somewhere with this. It's called MyBean. I don't like that name, so I'm going to actually rename this to TaskBean. All right, that's better. Let me add an ID field here. I'm going to generate a getter and setter for this. Let me reformat the file because that's a bit ugly. All right, cool. So now I have a bean with an ID field. All right. Now, okay, my endpoint. So this is where we actually want to put in the logic for what we're trying to do here. So I'm going to rename this to Task API instead of My API. I'm going to drop out the say hi method because we don't need that anymore. And I'm going to drop in some code here. And I'm going to and this is going to be code to talk to the data store. And it's going to expose 3 methods: clear tasks, get task, and store task. Right? Get task will retrieve tasks from the data store. Store tasks will store a task in the data store. And clear tasks will delete all of them from the data store. But I'm going to drop in this code, and then I'm going to talk through what I did here. All right. So I've just dropped in a bunch of code, and I'm just going to resolve these imports here. I'm going to use the data store entity. Let's see. I want to use the app engine fetch options. I want to use Java util list. Cool. I think I got them all. OK, great. Oh, there are actually a couple of other errors here. This one is actually complaining because Task API, it starts with a capital letter here, but when you're using these REST APIs, you're supposed to start with lowercase letters. So I can just fix that. That's a validation that we wrote. And I look here at the get task method, and also I've got a dot in the name. It doesn't like that either. So I'm just going to fix that up. And just to let you know, when you're writing these endpoint classes, there's a lot of helpers for all these conventions. If you go under inspections here, you can see under Google Cloud Endpoints, you don't have to read them all, but there's a variety of things that'll help you with as-you-type validation as you write Cloud Endpoint classes. OK, great. So what did I actually do here? So I've created 3 methods. There's store task, as I mentioned to you, get tasks, and clear tasks. So to go through these really quickly, I'm using the data store service here. And what I'm doing in store tasks, I'm basically creating a new transaction. And then for a task being that's coming in from basically a client, I'm creating an entity for that, and I'm putting it in the data store, and I'm committing that transaction. Get tasks runs a query over the data store for all entities of type TaskBean, creates TaskBean objects from them, and returns them to the caller. Clear tasks is similar, except it creates a transaction, does that same query, and then it blows away all the tasks that are in the data store and commits a transaction. So, OK, cool. So looks like we have our back end. So what we need to do now, I think, is actually, let's just see where we are, so I can keep track of where we are. OK, cool. Yeah, what I want to do now is I want to generate client libraries, right? I've got my back end. I've exposed it through Cloud Endpoints, but someone's got to use it, right? And the thing that we want to use it is an Android app. So we need to generate strongly typed client libraries so that we can use this on the other side. So let me go ahead and do that, actually. So I'm going to go to Tools, Google Cloud Tools. I'm going to pick Install Client Libraries. Okay, so this is doing a couple of things, right? What it's doing is it's doing a build of the App Engine app, because we've changed a bunch of the code, and it's going to then basically get all the meta information from the annotations, kick that up to a cloud service, which is going to take that meta information and say, oh, hi, you need Java. Here, I'm going to give you a bunch of Java source that you can use as a way to call the cloud endpoints from a client application. We grab that source, we compile it, and we install into your local Maven repository. So now you can access it on the other side in the Android app. So let's go ahead and actually go and use those client libraries on the other side. So now I'm going to go to the To-Do Text Touch application here, and I'm going to drop in the dependencies here. Right. So I've added a reference to the libraries that were generated, and this is referencing the local Maven repo. And because I changed the build Gradle file, I've got to do a sync. So let's do that. And while that's going on, let's just see where we're at here. All right, so basically we're getting to the last stage here, right? We basically have our back end. We've got our client application. We're generating the client libraries. Now what we need to do is override the parts where we actually call the cloud provider, the existing cloud provider from To-Do Text app, and use ours instead, the backend we created. So let's go and do that. All right, cool. Okay, so the magic of this actually all happens in a class called TaskBagImpl. Not a great name, I know. It's a TaskBagImpl. But anyway, there's basically two methods here, or four methods actually: push to remote and pull from remote. And these methods actually are doing what they're saying. They're pushing the task to the remote cloud provider and pulling from the remote cloud provider. And you can see in this implementation here, it's using the remote client manager, which is for the existing cloud providers. So let's extend this class and override these methods. I'm going to create a new class here, TaskBagImpl. I'm going to extend TaskBagImpl. And I'm going to drop in code that overrides these methods and actually calls our backend instead of the existing backend here. So let's do that. All right, I'm just going to walk through the code quickly here. So what we've got here is basically an endpoints TaskBagImpl. I'm creating a new version or a new instance of Task API, and that's really the thing that calls over it's the thing that we use to actually invoke remote methods on our back end. You'll see in the construction, I've overridden the root URL to point to 10.0.2.2. That's because when I run this in the emulator, the Android emulator, I want to run against the local dev app server, which is mapped to 10.0.2.2. In push to remote, really, I'll just go through this really quickly, but we're basically grabbing the list of the tasks that are stored in the local Android store, creating task bean objects, and then calling store tasks for each one of those. When we call execute, that's when the HTTP call happens to our back end. In pull from remote, we call get tasks, which is the name of the method we defined on that side, execute, and we call get items, and then for each one of those, we create a new task object, which is what the UI understands for this app, and we call reload, and that shows them up in the Android application. So let's go ahead and just run this. Let's try this out, actually. So what I'm going to do is I'm going to run the back end locally. And while that's actually going on, I did remember there's one thing I do need to change here. I need to use our new actual, the endpoints TaskBagImpl. So I'm going to change that here. Whoops. Cool. So it looks like the dev app server is running. That's great. And now while that's running, I want to run the client app. So I'm going to run that. That's going to cause a Gradle build to happen here. You can see that basically in the build process, it's actually going ahead and doing both the debug and release builds of the application. You get that by default. And you can actually define many other variants of your application very easily with in Gradle. So I'm going to choose the running emulator here. All right, let's kick over to the emulator and see if we're working here. OK, cool. All right, so we're running the emulator here. So let me add a task. Okay. Cool. Add another one. Okay. I'll mark this as complete. And let's just see if, let's see what the actual, let's look at the back end and make sure we're actually storing data and I'm not, not deceiving myself here. So I'm running the API Explorer. You notice the API definitions are now mapping to Task API. I'm going to call get tasks here. And basically you see the data here. You see hi there, hi cloud platform people with the X. It's been marked as completed. That's why there's a line through it. So it looks like we're up and running there. Cool. So this is great. This is good times. But one thing we actually need to do is, well, hey, like we need to get this to production, right? I mean, that was the whole point of the exercise. So let's go and let's do that. So what I'm going to do is I'm going to do a little housekeeping here so you can deploy this. All right. OAuth 2. I want to use OAuth 2 authentication. I want to make sure my app ID is set properly here. Cloud Platform Live 14. Great. And what I'm going to do is deploy this from the command line because I mentioned we're using Gradle, so I should be able to do that, right? So let's do Gradle W to do text backend. Call app engine update, which uses the Cloud SDK under the hood. And all right, cool. So before doing this, it does a build. Looks like it's going up there. There's an updated SDK, so should grab that. Anyway, cool. So it looks like it's deployed. Let's go and all right, cool. Let's actually use the production backend on the phone there.
Yeah. Let's do that, Rajiv. All right. So let's see if I'm more lucky this time with my fancy tablet. So if we could cut to the device. Black screen. Hold on. Let's try one more time. Unplug, plug back in. That solves all the problems most of the time.
What
unplug, plug back in.
Oh no, that's me.
So we try the phone one more time. Okay.
Yeah,
If that doesn't work, let's
the
use the tried and true methods. Okay, still nothing. And
try one more.
And one more?
Yeah.
There we are.
All right.
Okay. So, Rajiv, what do you want me to add? So first of all, let me delete this. Let me delete this hero task, and then
just I don't know. Say
wrap up.
Yeah, wrap up. I like Rajiv. I don't know. Any of those things are fine.
All right, man. Okay, so I've tried adding a wrap up task.
All right.
And now if you go to developers console.
Cool. Can you flip over to the demo computer? All right, I'm going to refresh this here. There we go. Wrap up. Cool.
All right.
All right.
This is a good time for applause.
Thank you.
All right. Thanks, man.
Sure.
So seriously, I know this might not have been the most exciting demo of your lives, but this was no smokes and mirrors. In 15 minutes, we took this stripped out app and we added a cloud backend to it. So I thought it was kind of cool. And you've seen things like local dev app server and API Explorer and how code gets translated from Java to REST and all of those cool things. So anyway, if we can go back to the slides, I know you guys are eager to get to the fireside chat with Urs and Jeff Dean, so I'll just quickly blast through these slides. I would just like to mention that while some of these things are really cool, what we have now, more of the exciting things are coming, including support for GCE and improved getting started experience, API analytics, third-party client access, and all of those kinds of things that you can look forward to in I/O in 2014. So I hope to see you all there. Thanks so much for coming. Thanks for being attentive after the lunch. I understand that can be quite hard. And any questions? Yes. Actually, do we have a mic? Yeah, if not, you can just yell the question. I'll repeat that. Yeah, so that's a very good question. Let me just repeat it. The question was mostly, cloud developers are using other IDEs outside of Android Studio, and Android Studio is mostly Android. And so what's the further long-term plan there? So our goal is to meet you where you are. And so partially, one reason for that was having the Gradleified backend and frontend build. Currently, Android Studio supports just Java. There might be some things on the roadmap to extend that. Unfortunately, that's all I can give at this point. Yeah, thank you.
Though one reason we did, we wanted to say the backends that we're creating there, especially in Android Studio, are really attuned to be used by Android apps, right? So that's why it's still in Android Studio. It's like just add a cloud backend very easily for the purpose of your Android app.
Mm-hmm. Okay, last question. Okay, the question was, will there be support from Android wearables and Google Glass?
I mean, yeah, we haven't thought about that, but technically, right? I mean, with cloud endpoints, if you're using, if it's a Java, you can generate bindings in any language, and you're using HTTP, right? So I don't see, we haven't thought about it, but I don't see any actual technical reason why that would be a problem.
Yeah.
To use an app or a cloud-based backend and cloud endpoints to expose it to a device like that.
Yeah. All right, thanks so much, guys. Thank you.
Thanks. Nice, man.